Your work is going to fill a large part of your life, and the only way to be truly satisfied is to what you do believe is great work, and the only way to do great work is to love what you do, says Steve Jobs. So, with the same love towards work, let us start our day. A fabulous morning to everyone gathered here. B. Usha and Ranjani from Department of Physics going to host this event. Research is a formalized curiosity. It is rocking and firing with a purpose. With the same curiosity, we welcome all of you to this first international conference on progress, material science for sustainable energy, environment and health, organized by Department of Physics, Periyar Maniamai Institute of Science and Technology, and jointly organized by ABBM Sri Pushpam Pundi College, Tanjavur. Let us begin this day with Tamil Thai Valthu. I kindly request everyone to rise for Tamil Thai Valthu.
நீராடும் கடலொடுத்தனிடமடந்த கிளிலொழுகும் சீராரும் வதனமென திகழ்பரத கண்டமெது தெக்கணமும் அதிசிறந்த திராவிடன திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறமியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
I request everyone to settle down. Sunshine is a welcome thing. It brings a lot of brightness. So, to bring the sunshine, I invite Dr. P. Gayatri ma'am to deliver the welcome address.
Very pleasant good morning to all. Before proposing the welcome address, I would like to thank our management for providing the opportunity to conduct the first international conference in physics department. Special thanks to our honorable board member Mr. V. Anburaj sir for constantly supporting and guiding us to conduct this international conference. And today we are having a renowned scientist here because of Dr. V. Anburaj sir. Now I start my welcome address. First, I would like to welcome our chief guest, Dr. S. Gunasekaran sir, founder, president, ISPA, and currently he is Dean R&D in the St. Peter Institute of College, Chennai. And I want to highlight a few points regarding our chief guest. And we can say about our chief guest for the whole day, but I want to highlight a few points about. So, Dr. Gunasekaran sir is founder ISPA and president, and he is currently working as Dean R&D, and he has guided 83 students, PhD students, and we can give a round applause for sir. And he has 469 publication in reputed journal, and H index he is having a 46 and I index 213 with 9,000 citation. Sir, really great sir. So welcome you sir. Next, he is a referee of many reputed journal, and he has international collaboration research project with Medical University Bulgaria of 250 million, that is 1,000 crores in Indian rupees. He has a collaboration, and he himself is having 86 ISPA Dr. Gunasekaran Award, and he is giving for every year for young researcher for this ISPA award, and he has authored 14 books for higher secondary school education. And not only he is a good researcher and academician, he is also served as a registrar in Periyar University, Salem. And the highlight of this is he is a top 2 scientist of world ranking announced by Stanford University, Tamil Nadu. So Stanford University, and he has won many award, and we can say a lot of award. One thing is he is a number one Tamil Nadu scientist. He is okay, sir. Really, we are very much fortunate to have you as a chief guest here. Welcome you, sir. Next, I would like to welcome our Honorable Vice Chancellor, who is a dynamic Vice Chancellor for our university, and he is a good academician, and he is supporting a very lot for our institution, and he is doing lot things, and lot more things have to do in our university, sir. Welcome you, sir. On behalf of Department of Physics and the entire team conference, we welcome you, sir. Next, I would like to welcome our hosting department, Dr. K. Ravichandran, sir, Associate Professor and Head PG Research Department of Physics, AVV Sri Pushpam College, Pundi. Another scientist, he is also a scientist, and he has guided 25 students. And in Tanjavur belt, he is doing a best research in our Tanjavur area. Sir, welcome you, sir. Next, I would like to introduce another scientist here, Dr. P. Balakumar, sir, Director, Center for Scholarly Scientific Training and Research, PMIST. He is going to felicitate the gathering, and welcome you, sir. Next, another speaker, great speaker, that is Dr. R. Ramesh Babu, sir, Professor and Head, Crystal Growth and Thin Film Laboratory, Department of Physics, Bharathasan University, Trichy. Sir, we welcome you, sir. Next, I would like to welcome our founder, former Dean Research, Professor D. Kumar, sir, currently in Professor in Physics, and he is also one of the scientists. So welcome you, sir, on behalf of team. And next, I would like to welcome the Dr. Anandi, Assistant Professor, Physics, coordinator of this conference, who is going to propose a vote of thanks. Welcome you, ma'am. Also, I would like to welcome Dr. S. Ravi Shankar, another coordinator in AVMC Pushpam College. Welcome you, sir. Finally, I would like to welcome all the faculty, students of PMIST, and faculty and students from various institute and college. Welcome you all. Thank you.
Thank you, ma'am, for your warm speech. Now it's the time to honor our chief guest. As a token of appreciation and respect, we would now like to invite our esteemed Vice Chancellor, Sir, Professor V. Ramachandran, Sir, to present the shawl and memento to our chief guest, Dr. S. Gunasekaran, Sir. Now, I request our Vice Chancellor, Sir, to honor our chief guest, Dr. Ramesh Babu, Sir. Now, I kindly request Dr. K. Ravichandran, Sir, to honor our Vice Chancellor, Sir, Dr. B. Ramachandran, Sir.
Second, the second
Now, I invite Dr. D. Kumar, Sir, to present a token of appreciation to Dr. P. Balakumar, Sir.
Ramesh Babu.
Now I request our Vice Chancellor sir to honor our chief guest, Dr. Ramesh Babu sir.
கார்டுல இருக்கு பாருங்க.
Research is saying what everybody else has seen and thinking, what nobody else has thought. Now, I would like to invite such a thoughtful person, Dr. K. Ravichandran sir, Associate Professor and Head, PG and Research Department of Physics, AVVM, Sri Pushpam Pundi College, to deliver the paramountcy of the conference.
Very good morning, one and all. Honorable Vice Chancellor of this illustrious institution, the most respected Chief Guest, Dr. S. Gunasegaran, founder of ISPA, respected Head of the Department of Physics, Bharatdasan University, Dr. Ramesh Babu, respected Dr. Balakumar, Director, PMIST, respected Gayatri, Organizing Secretary, Organizing Committee members, Dr. R. Ananthi, Dr. S. Ravishankar, Senior Professor Dr. Kumar, faculty members, research scholars, and my dear young student friends. First of all, I would like to thank the university authorities and organizing committee for having given me this opportunity to present the conference note. As one of the conveners, I am very much pleased to be a part of this conference on progress in material science for sustainable energy, environment, and health. Continuing the legacy of the great Periyar and Madam Maniammai, under the headship of Asiriyar, this institution is serving the society and the student community by inculcating scientific spirit to all. As part of this service, this international conference is organized in collaboration with the AVVM Sri Pushpam College, Pundi, one of the renowned institutions in the Delta region. Research in material science sheds light on the properties of materials under different conditions and leads to the development of new cost-effective technologies for preparing materials with tailored properties suitable for various applications. This international conference will provide a perfect platform to bring together eminent scientists, academicians, research scholars, and students from various colleges and universities who are actively involved in research in the area of material science to strengthen the networking and research in their respective fields. Particularly, the participants in this program are going to present their research findings on topics which include green synthesis of nanomaterials, supercapacitors, gas sensors, thin films, photocatalysis, etc. 7 invited lectures are to be delivered, including the one by the legend Dr. S. Gunasegaran sir, Apart from the invited lectures, 61 oral presentations and 50 poster presentations are scheduled. Delegates from 17 institutions are participating in this conference. In total, there are 260 registrations so far. 60 more participants are to be joined with us in the second day tomorrow. I hope this conference will be beneficial for the research community and the students. Thank you.
Thank you, sir, for this delightful speech. Now, the release of conference proceedings. Welcome to the official release ceremony for the abstract proceedings of the first international conference on progress in material science for sustainable environment, energy, and health. To all our esteemed guests, thank you for your valuable contribution to this conference proceedings. Your support has been instrumental in fostering a platform for international collaboration and knowledge exchange. Now, let's turn our attention to release of the abstract proceedings for this international conference. I would like to invite Dr. S. Gunashekhran sir to the stage to officially release the abstract proceedings. I thank everyone who are involved in making this ceremony a successful manner. Management is about arranging and telling. Leadership is about nurturing and enhancing. Such a person who has enhanced many students. Now I'd like to invite our Honorable Vice Chancellor of PMIST, Professor V. Ramachandran, sir, to deliver the presidential address. Please, sir.
Good morning, all of you. Really, today we are honored in this grateful morning to stand before prominent researchers and scientists of our states. I really astonished to go through the profile of Dr. S. Gunashekhran, the chief guest, the founder president of Indian Spectrophysics Association. Really, there is no words to give our gratitude to our chief guest today on seeing his profile of completing 83 research scholars so far and continuing research and also guiding now also at this age of 70, I think so. And really wonderful moments. And he got DSc from University of Madras, Doctor of Science after PhD. Really, we are having a apt chief guest for this first international conference on progress in material science for sustainable energy, environment and health. Sir, we are very happy to and we are proud to have you here for this conference. Thank you, sir. Again, this conference was jointly organized by Periyar Maniammai Institute of Science and Technology as well as AVVM Sri Pushpam College, Kundi. Further, I came to know Professor K. Ravichandran professor and head of physics department. He is also doing extraordinary research in the field of physics. At this young age, he guided more than 25 students, and also now he is furthermore guiding. Thank you, sir, for giving this opportunity to organize this combinedly in our institution. And all the professors sitting here, including Balakumar and Kumar, other professors also, they are doing extremely good research in this campus. And I heard about Professor Kumar very recently. He completed his MTech and PhD in IIT Madras in biomedical engineering. He is also a good researcher. And our keynote speaker today, Dr. Ramesh Babu, really, we are having prominent people on the dais, those who are going to give their lectures after this inaugural function is over. The theme of this conference, the progress in material science for sustainable energy, environment and health. It underscores the importance of these domains and the preparedness of developing holistic approaches to address them. As we all know, material science stands at the forefront of technological advancements, offering transformative solutions for sustainable development. As we convene here today, we are reminded of the crucial role of materials play in shaping the future of energy, environmental conservation, and public health. From renewable energy to population control strategies, and from biomedical applications to sustainable practices, material science offers a diverse range of tools and techniques to drive progress towards a more strong and sustainable world. I'm sure this conference will serve as a platform for sharing new ideas, partnerships, and initiatives that will propel us closer to our shared vision of world where energy, environment, and health is safeguarded. Let us seize this opportunity and reaffirm our commitment for advancing the boundaries of material science for the betterment of humanity in the future. I appreciate the organizers, dynamic people of this department, paper presenters, and participants for your wonderful contributions. Thank you, one and all. Thank you for this opportunity.
Thank
Again,
you.
again, I'm really proud of having these eminent people on this dais. Both are DSCs. One is from Madras University, another DSC submitted to Periyar University. Very happy, sir. Thank you, sir.
Thank you, sir, for your enchanting speech. A scientist should always be open minded and willing to accept new ideas, even if they contradict existing beliefs. The person who is always willing to get new ideas and gives his full support and guidance to his students. The man full of simplicity and vision. Now, I would like to invite Dr. S. Gunasegaran sir, founder president ISPA, to deliver the inaugural address.
Honorable Vice Chancellor of this great institute, Periyar Maniammai Institute of Science and Technology, Tanjavur. Sir is a motivational force to not only to the faculty members of this institute, also avid researchers. Really is a dynamic Vice Chancellor. I got motivation after having a discussion with Professor Dr. V. Ramachandran during the last nearly 45 minutes. He is a motivation force. Honorable Vice Chancellor Professor V. Ramachandran sir and Director of Center for Scholarly Scientific Training and Research, PMIST, Professor Dr. P. Balakumar. Beloved crystal grower, scientist in the field of crystal growth, HOD of Physics of Bharatidasan University, Tiruchirappalli, Dr. R. Ramesh Babu. Dr. Kumar, Director of Research and Development of this esteemed institute. Vibrant HOD, vibrant convener of this 2-day international conference. Beloved Dr. P. Gayatri, avid researcher, very good organizer, and another convener of this conference, Dr. K. Ravichandran, Dr. Ravi Shankar, Dr. R. Anandi, learned members of the Department of Physics, professors from various departments, my dear young budding scientists, scholars, participants, delegates, young philosophers, Vanakkam, Vantanam, Namaste, Namaskar, Suswagatam, Salam Alaikum, and good morning to one and all. I deem it a great pleasure to have involved myself as one among you with this 2-day international conference on progress in material science for sustainable energy, environment and health, organized by the Department of Physics of this esteemed university, Periyar Maniammai Institute of Science and Technology, in association with PG and Research Department of Physics, AVVM C. Pushpam College Autonomous, with the coordination of my good friend Dr. Ravichandran. It is my pleasant privilege and a proud duty to express my sincere thanks to the organizers, especially Honorable Vice Chancellor Ramachandran sir, conveners of the conference, Dr. Gayatri Madam, Dr. Ravichandran, for having given me an excellent opportunity to stand before you and speak to you with this inaugural session of this 2-day international conference. My dear friends, this is a big moment for me because I am addressing senior scientists who are present on the dais, young budding scientists who are present on the dais, great philosophers who are present on the dais, young philosophers who are present on the dais, whom I regard as very important members of our scientific community. You should know the meaning of philosophy. Phlos is one word. Sophia is another word. Words were taken from Latin language, British people. They have combined these two words together to get philosophy. Doctor of philosophy. What is the actual meaning for doctor of philosophy? You must know the weightage of your degree, PhD, doctor of philosophy. Because we are all young philosophers, the people are great philosophers. Phlos. What is the meaning? Knowledge. Sophia. Love. அறிவை நேசிப்பதில் you are all doctor, that is a doctor of philosophy, PhD. This is a weightage given to the degree PhD. You must know the actual meaning for philosophy. That's why I mentioned young philosophers and great philosophers. My dear friends, organization of an event is not an easy task. Under the banner of Indian Petrophysics Association, ISPA has organized more than 100 events, state level, national level, international level. Even my good friend Dr. Ravichandran, she knows better what are the difficulties involved in the organization of an event. It is a kind of service. You take H2O molecule. I am a molecular physicist. Water molecule. If you want to arrange 10 lakhs water molecules along a line side by side, which comes around only 1 millimeter. All water resources on this globe, on this planet, all the water resources give water molecules to each and every living system without expecting anything in turn from us. The kind of service is one observation from nature. How large amount of water molecules we consume from water resources every day? You take air. If you take 1 cubic centimeter volume of air, which contains 2.7 into 10 power 16 air molecules at NTP, normal temperature pressure. This is the data given in 5th standard science book published by NCRT, New Delhi. பையன் கேட்கலாம் அப்பா கிட்ட, suppose I want to remove 10,000 air molecules per second from this 1 cc volume. What is the time taken to exhaust all the air molecules from this 1 cc volume? Make calculation, which is found to be 8,40,000 years. How large amount of air molecule is present in a small volume of air? How the large amount of water molecules, oxygen, we consume from atmosphere freely. Atmosphere gives you full of water molecules to each and every living system on their surface without expecting anything in turn from us. This is observation from nature. Second observation. Dr. Ravichandran, Department of Physics, Dr. Gayatri, with the able leadership of Honorable Vice Chancellor Professor Ramachandran, they are organizing this kind of activity by inviting number of eminent speakers, not only from India, also from abroad. They are doing an excellent service for promotion of research in the country without expecting anything in turn from the society, even appreciation, recognition. That is a concept. My dear friends, a dream does not become reality through magic. This is not my statement. A dream does not become reality through magic. It takes sweat. Sweat means energy and money. High determination and hard work. This very good saying offered by Mr. Colin Powell, US Secretary of State during George Bush. Our statement. I mean, energy, money, high determination, hard work. All these four could be considered as four wheels of a motor car. That is energy, money, high determination, hard work. If these four wheels are not synchronized properly and allow the car to run on its own will and wish, just imagine what happens to the fate of the body of the car. But here, Department of Physics of this esteemed university, with the collaboration of Pushpan College, with the guidance of Dr. Ravichandran, with the able leadership of our Vice Chancellor, they have synchronized all these four wheels properly. That's why they have succeeded in this endeavor today. On behalf of the Indian Spectrophysics Association, I should congratulate whole team of workers for having organized an excellent program in this esteemed institution today. கை தட்டுங்க. மேடம் சொல்றப்போ ஒண்ணு மட்டும் மறைச்சிட்டாங்க. நோட்டீஸ் பண்ணாங்க, பிரீஃப் பயோடேட்டா சொன்னாங்க, ப்ரொஃபைல் ஒண்ணு மட்டும் வேறும்னே மறைச்சிட்டாங்க. உங்க விசியை மறைச்சிட்டாங்க. கொஞ்சம் கோபம் தான். I did my BSc Physics in Tamil medium, Physics. அது கோட் பண்ணி கொடுத்துருக்கேன், போல்டு பண்ணி கொடுத்துருக்கேன். ரெண்டு பேரும் மறைச்சு படிச்சுட்டாங்க. தாய்மொழி வாயிலாக படித்தால் சாதிக்க முடியாது என்ற தவறான கருத்து ஒவ்வொரு மனதை விட்டு போக வேண்டும். My dear friends, you take our former president, late APJ Abdul Kalam. He has offered in the parliament, by 2020, India should become superpower. 2020 illa, takes another one decade. Our former Prime Minister of India, late Sri Rajiv Gandhi, he has told the parliament long before, the going 21st century is unavoidable in the present scenario. The statements offered by these two eminent personalities are really 100% true. 100% true. You take what is the agenda of India in the global scenario. H-index, X means which defines the quality and the quantity of the work undertaken by the scientists, the field of science and engineering, including medical, agri, everything. Scientific community in India, comparing global scenario, H-index, we are in the 7th place. 200க்கு மேற்பட்ட இருக்கிற கண்ட்ரியில நம்ம இந்தியா 7ஆம் இடத்துல படிச்சிருக்கோம். கை தரக்கூடாதா? Number of citable documents published by the scientific community in India, citable documents, we are the third place. That's why I told you, the statements offered by these two personalities are really 100% true. 100% true. The organizations have taken, they are given the very fantastic title. That is, Progress in Material Science for Sustainable Energy, Environment and Health. More suitable the present scenario. We have to accept. Everything is in materials. We are living in the world of modern materials. Without materials, no life. Materials of modern world. Advanced materials. Biomaterials. Biological materials. Pharmaceutical materials. Diamond materials. Diamond-based materials. Electronic materials. Ferroelectronic materials. Fluorescence material, luminescence material, magnetic materials, superconducting materials, materials for defense applications, materials for solar energy, materials for energy storing devices, crystalline materials, NLO materials, photonic materials, smart materials, nano materials, 2D materials, etc., etc. With the characterization of the materials, one should think about their application. That's it. Synthesis, characterization, and application. You have to see the application. Then only research will be complete. That is called the research excellence or real research. Real research. Concept development for inspiring innovation to bind science and society. These annotations coined by Indian Spectrophysics Association. Synthesis, characterization, application. That is a research excellence. You should know sizes from macro to molecular level in nanometer. If the material size is greater than 10 power 4 nanometer, they are called bulk materials. That is a macromolecules. 10 power 3 to 10 power 4 nanometer. MEMS devices on a silicon chip, including living cells. 1 to 100 nanometers. Proteins, DNA, including nanoparticles. 0.5 to 1 nanometer, small molecule, there is a molecular level, IR spectroscopy, Raman spectroscopy. 0.1 to 0.5 nanometer, chemical bond, that is atomic level, atomic spectroscopy. My dear friends, how to understand the nano scale parameter? For comparison, C single bond C is equal to 12 to 15 nanometer bond distance. DNA double helix has a diameter around 2 nanometer. To be precise, the comparative study of nanometer to meter is equal to size of a marble stone divided by size of earth. You take width of human hair, single human hair, 50,000 nanometer. You take outermost layer of our human skin. What is the thickness? 100,000 nanometer. These will explain and make one to understand about the sizes from macro to molecular level. You are going to study the research in the areas of material science. Characterization of the materials is the most important area in the material science to get information of structure of processing and performance. Two ways to perform our programs, research programs. There are only two ways. One is as though nothing is miracle. The other one is as though everything is miracle. நீங்க ரிசர்ச் ஸ்டார்ட் பண்றப்போ இந்த டூ வேஸ் நீங்க திங்க் பண்ணிக்கணும். ஒன் டைம் an hydrogen atom last is single electron. இருக்குது hydrogen atom atomic number 1, only one electron, the first orbit, K shell. That hydrogen atom last is single electron. Hydrogen atom went to the police station to lodge the electron missing report. The police department questioned the hydrogen atom. Are you sure that your electron is usually really lost? Are you sure that your single electron is really lost? I am positive, replied the hydrogen atom. Yes, negative சொல்லவே இல்லையே. I am positive. Absence of electron is nothing but presence of holes, positive charge. That's all positive. This reply is positive attitude, my dear friends. Physicists, we do everything miracle because physicists do it with a positive attitude. Quantum physicists do it in a quantum at a time. Particle physicist, do it with a charm. Astrophysicist, do it with a big bang. Practical physicist, do it energetically. Crystal physicist, do it with sparkle. Spectrophysicist, do it at the speed of light. Because of all these qualities, my dear friends, physicists have visualized so many miracles with modern materials. They have chosen very good topic. Environment and health important. Our earth is facing a lot of physical problem to have resources like water and air. More than 2000 inorganic, organic and metal pollutants are present in water because of the developments in the field of science and technology. Our air is polluted with three major air pollutants. Carbon monoxide from the automobiles, sulfur dioxide from chimneys of factories, chlorofluorocarbon during the fabrication of the electronic chip in the electronic industry. For example, one major electronic industry in America, they produce more than 10 million IC741 chip every year, operation amplifier. Every year they produce more than 10 million chip, 8088 chip, microprocessor, into the microcontroller. So during the fabrication of ICs, one major electronic industry see the problem. There are more than 1,000 manufacturers in states alone. What are other countries? Carbon monoxide, sulfur dioxide, chlorofluorocarbon during the fabrication IC. They are moving vertically upwards slowly. They disintegrate the ozone layer thickness. Day by day, the thickness of ozone layer become thinner and thinner. That's why we are affected by harmful UV radiations. Maybe after 100 வருஷம் பத்தி பாருங்க, there won't be a suitable temperature condition on the surface. Temperature மேல போயிடும், global warming. So there won't be a suitable temperature condition for all living systems, plant system, animal system, including modern animal system. Therefore, my dear friends, we have to think about tomorrow's habitat. Tomorrow's habitat. It's a very, very important thing. அதான் மென்ஷன் இருக்காங்க, என்வரான்மெண்டல் ஹெல்த்னு கொடுத்துருக்காங்க பாருங்க. முன்னோரை கொடுத்த இந்த எர்த்தை சேஃபா கொடுத்துருக்காங்க. பாதுகாப்பு சேஃபா நம்ம பின்ன இருந்து தர வேண்டிய கட்டாயத்தை தள்ளப்பட்டிருக்கிறோம். There is a bound duty for which we have to do an extensive research work. How we can produce electronic chip without emission of CFC, that is important. We have to do research. By now, we have realized the potential and the promise. The present conference on this title, scheduled to take place today, holds for the common man different industries, researchers and scientists. Dear friends, the deliberations and discussion of this two-day program definitely take you further. Enhance your research work in your specialist area. But quality is very, very important thing. Senior researchers, we are all junior researchers. ஒரு ஜூனியர் ரிசர்ச்சர் ஒரு சீனியர் ரிசர்ச்சர் கொஸ்டின் பண்றார். என்ன கேக்குறீங்க? How to provide quality research for which the senior researchers he has given the very good reply. To provide quality research work, வேற ஒண்ணுமே இல்லை, 4 மைகள் இருந்தா போதும். 4 மைகள் இருந்தா போதும். சந்தோஷமாயிடுச்சு. எனக்கு கருப்பு மை இருக்கு, பேனா ரெட் மை இருக்கு, கிரீன் மை இருக்கு, ப்ளூ மை இருக்கு, போதுமே. We can provide quality research work. தம்பி அது இல்லை, மை திறமை, தனிமை, பேராமை. இந்த 4 மைகள் இருக்க வேண்டும். My dear friends, பெறக்கூடாத மைகள், that is plagiarism, கயமை, பொய்மை, மடமை, வேற்றுமை, இது தொடக்கூடாத மைகள். தொட வேண்டிய மைகள், that is பொறுமை, திறமை, தனிமை, பேராமை. தொடக்கூடாத மைகள் கயமை, பொய்மை, மடமை, வேற்றுமை, that is plagiarism இருக்கக்கூடாது. தொட்டு எழுதக்கூடிய மைகள் எது? நன்மை தரக்கூடிய நேர்மை, திண்மை கொண்டிருக்கும் புதுமை, புதுமை தரக்கூடிய செம்மை, வலிமை தரக்கூடிய உண்மை. இந்த நோக்கத்தில் ஆராய்ச்சியாளர்கள் தங்கள் கடமையாகவும் உறுதியாகவும் கொண்டு நமது இந்திய நாட்டிற்கு பெருமை சேர்க்க வேண்டும். This is born duty. For which we have to adopt 2-tier management system. Another 3 minutes mission. எனக்கு கொடுத்தது 20 minutes தான், 5 minutes எக்ஸ்ட்ரா எடுத்திருக்கேன். இன்னும் 2 minutes முடிச்சுடுவேன். To provide quality research work, we have to adopt 2-tier management system. What is first tier? Time management. அன்னை தெரசாவுக்கும் உலகை வென்ற அலெக்சாண்டருக்கும் பல அற்புதங்களை கண்டுபிடித்த தாமஸ் ஆல்வா எடிசனுக்கும், ஏன் அமெரிக்காவின் ஆப்ரஹாம் லிங்கனுக்கும், ஏழை தொழிலாளருக்கும், ஏன் உனக்கும் எனக்கும் இந்த இயற்கை பாரபட்சமின்றி ஒவ்வொருவருக்கும் சரிபாக கொடுத்திருப்பது ஒரே இதுதான். என்னங்க? நேரம் தான். நேரத்தை வீணாக்கின்ற பொழுது நீங்கள் உங்கள் கடிகாரத்தை பாருங்கள். ஒவ்வொரு மூலியல்ல உங்கள் வாழ்க்கை. This is time management. Then brain management. Einstein, he invented 3 major discoveries in the year 1805. Photoelectric effect, for which he got the Nobel Prize, Brownian movement, including theory of relativity. Great scientist. அவர் தெருவோரமா போயிட்டு இருக்கார். எதிர்க்கு ஒரு பையன் வரும், வெறும் ஃபுல்லா அழுக்கு. தம்பிங்க வா, வெறும் அழுக்கா இருக்கு, தண்ணி நல்லா வாஷ் பண்ணி கிளீன் ஆகும், வந்தேன்னா இந்த காயின் உனக்கு தரேன். பையன் போறோம், நல்லா வாஷ் பண்ணிட்டு காயின் கொடுத்துட்டார். என்ன சொல்றேன் பாருங்க, ஐயா நீ சொன்ன நான் உதவி பண்ணி செய்வேன், காயினும் வாங்கிட்டேன். ஆனா உங்க தலைவிரி போலதான் இருக்குது. நீங்க தலைவியை ட்ரிம் பண்ணிட்டு வாங்க, நீங்க கொடுத்த காசுல திருப்பி தரலாம் பையன். அன்பு மாணவ கண்மணிகளே, அழகு என்பது உடல் அல்ல, அறிவில் தான் இருக்கிறது. This is called brain management. After the death of Einstein, his brain was removed from the body and put in a jar for further investigation. This is called the brain management. தன்னம்பிக்கையும் நேர்மையும் கொண்ட எந்த ஆணும் அழகான், கனிவும் பணிவு கொண்ட எந்த பெண்ணும் அழகுதான். Don't dream about your duty. That will spoil your duty. Dream about your duty. It will make your life very beauty. Innovations come from creativity. That creativity comes from beautiful mind. Beautiful mind, my dear friends. நீங்கள் நிம்மதியில் வந்தால் அந்த மேமலையில் உங்களுக்கு இடம் கொடுக்கும். நீங்கள் உடனே கிடந்தால் அந்த சிலந்து வலையில் உங்கள் சிறை பிடிக்கும். நீங்கள் தவறை கிணற்றில் விழுந்து விட்டால் கவலையே படாதீங்க, வாய்ப்பை பயன்படுத்தி குளித்து விட்டு வாருங்கள். Get ready, go ahead, kindly participate in all your research activities, demonstrate your full skill, get awards and rewards, make it a record. Wish you all good success. Thank you very much.
Thank you, sir, for a positive attitude will not solve all our problems, but that is the only option we have if we want to get us out of the problems. Now, I would like to invite such a person, a man full of positivities, Dr. Balakumar Pichi, sir, to deliver the felicitation address.
most respected Honorable Vice Chancellor of Periyar Maniammai Institute of Science and Technology, deemed to be university, the great academician, the great administrator, and above all, a great human being, Professor Dr. V. Ramachandran sir. Next, the great academician, the senior most scientist of India, the founder president of ISPE, Professor Dr. S. Gunasegaran sir. Other dignitaries, Dr. B. Gayatri, Head Department of Physics of PMIST, Dr. K. Ravichandran, Head PG Research Department of Physics at AVVM Sri Puspam College, Pundi, Dr. R. Ramesh Babu, Head Department of Physics at Bharatidasan University, Tiruchirappalli, Dr. S. Ravisankar from Department of Physics at AVVM Sri Puspam College, Pundi, Professor Dr. Kumar, the former Dean Research of Periyar Maniammai Institute of Science and Technology, the dignitaries on the dais and off the dais, fellow colleagues, students, boys, girls, delegates, ladies and gentlemen, a very good morning to all of you. It is indeed a great honor for me to stand in front of you, and I would like to convey my sincere congratulations to the organizer who are organizing this international conference titled Progress in Material Science for Sustainable Energy, Environment and Health, that is being organized by the Department of Physics of PMIST in association with PG and Research Department of Physics at AVVM Sri Puspam College, Pundi, Tamil Nadu, India. Dear delegates, the purpose of this international conference is to share knowledge, to exchange ideas, and to learn from one another. And scientists like today we have Dr. S. Gunasegaran, having published more than 400 scientific articles that earned more than 9,000 citations with H index of 46 and along with ICAN index of more than 210. It is not a joke. It is not an easy way for anyone to achieve this milestone. Receiving one citation for the paper you have published in Web of Science Journal or Scopus Index Journal, it takes minimum 3 to 6 months. Means a person who are citing your paper and that he is submitting the paper for publication and the paper is accepted and eventually published, then you will get a one citation. And that citation may be a Web of Science or Scopus or non-industry citation, having received 9,000 citations. Really, we are truly honored to have you sir here. Dear delegates, I am sure you will carry a great amount of memories and knowledge who are going to be shared by eminent speakers of this 2 days international conference, namely, again, Dr. S. Gunasegaran, the founder president of ISPE, Dr. Ramesh Babu, the head department of physics from Bharatidasan University, Dr. Benito from the University de Lome, Togo, West Africa, and Dr. P. Saktivel from the Faculty of Engineering from Karpagam Academy of Higher Education, and Dr. S. Rajagopal from Department of Physics and Electronics at Jain, deemed to be University, Bangalore, and Dr. Vijay Kumar Sekhar, the postdoctoral research scientist who is working at Shandong University, China, and Dr. Yuvraj Sivalingam from King Abdullah University of Science and Technology, Saudi Arabia. Since we are together here, let us embark on the journey of knowledge sharing and collective development. Again, I'm sure you will carry a great amount of knowledge while you are leaving from this conference from today and tomorrow. Thank you, delegates, and have a wonderful day ahead. And I hope you will be having an enriching discussion today and tomorrow. Wish you all the best and good luck to the organizer. Thank you.
Thank you, sir, for your magnificent speech. The best scientists, the best scientists are those who believe in the potential of their ideas even when the world doubt them. Now, I would like to invite Dr. R. Ramesh Babu, sir, Professor, Crystal Growth and Thin Film Laboratory, Department of Physics, Bharathidasan University, young scientist, to deliver the keynote address.
Most esteemed Vice Chancellor of this institution, Professor V. Ramachandran sir, esteemed Principal, AVVM Pushpam College, Pundi, respected Registrar of this institution, and Professor Balakumar, Center for Scholarly Training and Research, distinguished Chief Guest Professor S. Gunashagan sir, Founder President ISPA, respected conveners of this conference, Professor K. Ravichandran and Professor K. Gayatri, and organizers, Professor Ravi Shankar and Professor Anandi of this institutions, dear faculty friends and my dear participants. A pleasant morning to each and every one of you. It is with great pleasure and humility that I stand before you to present a keynote address at this first international conference on progress in material science for sustainable energy, environment, and health. I think this gathering is a coming together of brilliant minds who are committed to tackling some of the most pressing challenges of our time. It is an honor to be among individuals who are leading the way in driving progress in these critical areas. Therefore, it is essential to recognize interconnected nature of the challenges what we are facing in our day-to-day life. For that, switching to renewable energy is urgent need for environmental and public health reasons. In this context, as Professor Gunashagan sir said, material science playing a vital role because it is at the forefront of our quest for sustainable solutions. Through the ingenious manipulation of atoms and molecules, our material scientists have unlocked a treasure trove of possibilities, enabling breakthroughs that promise to reshape our world for a better future. As far as environmental concerned, our precious planet is facing very many environmental issues, from pollution and deforestation to loss biodiversity of climate change. Here, Material science only offers a ray of hope, whether it is the development of materials for efficient water purification, innovative approaches to waste management, or the creation of sustainable building materials. Through this, our researchers are harnessing the power of materials to mitigate environmental degradation and promote conservation. In the meantime, so we need to enhance our health care as well as the public health. Advancing health care and promoting public health is also critically dependent on material science. So that the evidence of that one from the development of biocompatible materials for medical implants and drug delivery system to the creation of diagnostic tools and wearable sensors, and then material scientists. Through this one, material scientists are revolutionizing the way we diagnose, treat, and prevent diseases, ultimately improving the quality of life for millions around the globe. Even we have made progress in material science that has transformed to the sustainable energy like environment and health. There are still challenges ahead. By working together, we can overcome these issues. In this context, I wish and congratulate the conference organizers for conducting the wonderful conference to discuss various issues on sustainable energy, environment, and health in the material science. Also, I am sure to all the participants that definitely you will enjoy these 2 days with full of intellectual lectures. Let us commit to a sustainable future with clean energy, preserved environment, and good health for all. Let us use material science to build an equitable world. Thank you, one and all. Thank you for this opportunity.
Thank you, sir, for an astonishing speech. Gratitude is the powerful catalyst for happiness. It is this spark that lights the fire of joy in your soul. Now, I invite Dr. R. Anandi, Assistant Professor, Physics, PMIST, to propose the vote of thanks.
Good morning, everyone. It is my honor to stand before you today and deliver a vote of thanks on behalf of the organizers of the first international conference on progress in material science for sustainable environment, energy, and health. Firstly, I would like to express our sincere thanks to the esteemed dignitaries who graced this occasion with their presence. We are proudly grateful to our chief guest, Dr. S. Gunasegharan, Dean Research and Development, Software, for accepting our invitation and delivering an inspiring inaugural address. Thank you, sir. Then, our deepest gratitude goes to Professor V. Ramachandran, Vice Chancellor, PMIST, for his presidential address, providing valuable guidance for the success of this conference. Thank you, sir. We also extend our heartfelt thanks to Dr. K. Ravichandran, Associate Professor and Head, PG and Research Department of Physics, AVDM Sri Pushpam College, for highlighting the paramountcy of this conference and its significance in the field. We are grateful to our welcome address speaker, Dr. P. Gayatri, Head Department of Physics, PMIST, for setting the tone for this important event. Finally, a warm thank you to Dr. P. Balakumar, Director R&D PMIST, and Dr. R. Ramesh, Professor Head, Department of Physics, Bhadras University, for sharing their expertise and enriching the session with their insightful words. Thank you, sir. Finally, most importantly, I want to express our sincere gratitude to all the participants from various institutions joining us today with us. Your active participation, thoughtful questions, and engagement are critical to the success of this conference. We look forward to your continued participation and insightful contributions throughout the remaining days. With this heartfelt thank you, I declare the inaugural session of this conference officially concluded. We are excited to embark on the journey of learning, collaboration, and exploitation that awaits us in the upcoming sessions. Thank you once again.
Thank you, everyone. The commencement of next section will start after a short tea break. You may dismiss for a short break and report here by 11:30.
எல்லாம் ஷேர் பண்ணுறோம். நல்லா இருக்கு சார், நீங்க நல்லா இருக்கு. நேஷனல் கலெக்டர்
Welcome back, everyone. I hope you all are refreshed and energized for the next lecture session. Today, we are honored to have with us our esteemed chairpersons. She has 30 years of experience in teaching, guided 2 PhD students, 10 MPhil students, 26 MSc projects, and also she has completed a project in PMSSEEH and has published 25 research papers on vibration spectroscopy and received award from late Prime Minister Mrs. Indira Gandhi, gave lecture on topics space and mankind and got awards from late President Hidayatullah. Research person and gave lecture in more than 30 colleges. Now, I would like to invite Dr. Delvi Malal, EBR College Trichy, to introduce our speaker. Please, ma'am.
கட்டி தமிழே கவிதை பெருஞ்செவியே எட்டத்திக்கும் எழில் வளர்க்கும் பூமகளை என் தாய் தமிழாகிய செந்தமிழினால் நான் வாழ்த்து செல்வதற்கு காரணம் நம்ம இளம் ப்ரொஃபசர் குணசேகரன் சார் சொன்னாங்க, என்னுடைய தமிழை மறைத்து விட்டீர்கள் என்று. செம்மையான வளமையான புதுமையான நம் தாய்மொழி, உங்களின் அருமையான மொழி, எங்களின் அருமையான மொழி, அனைவரின் அருமையான மொழியை யாராலும் எப்போதும் எங்கேயும் மறைக்க முடியாது. அது நம் உணர்வு, நம் உயிர். Now let me start an introduction. Very good morning to one and all. Most respected dignitaries on the dais, off the dais, respected Vice Chancellor, Director, Dean of Sciences, Head of the Department, Convener of this Periyar Maniammal Institute of Space, Science and Technology, and the Convener, Head of the Department, Professor Dr. K. Ravichandran Sir, Shri ABVM, Pushpam College, Pune. I would like to thank personally Professor Dr. K. Ravichandran Sir, who has asked me to chair such a legend. I was searching introduction about our eminent scientist, Professor Dr. Gunasekharan Sir, but it was a very lengthy Himalayan achievement which was made by our chief guest of today's session. Really, being a spectrophysicist, I am very much delighted to take this opportunity to welcome our eminent professor for this morning session. Good morning, sir. Our eminent professor has completed his UG degree in Presidency College, especially in Tamil medium. And our professor has completed his PG degree in St. Joseph's College, Trichy. He has done his PhD degree in molecular spectroscopy in Anna University and postdoc in University of Madras. Now, he is the Dean of Science in St. Peter's Institute of Higher Education and Research, Chennai. In 1978, he started his research career, teaching career. Our chief guest of today's session, Professor Dr. Gunasegaran, is the post registrar of Career University. His areas of research in the application of spectroscopy, such as material science, medical physics, environmental science, and molecular dynamics. The term spectrophysicist was coined by our eminent professor. Our professor so far guided, as per our HOD madam said, 82 PhD candidates, and he published 430 publications with H index of 42, item index of 185, nearly 9,000 citations. And he is the founder and president of Indian Spectrophysics Association, ISPA. So, ISPA honored the Lifetime Achievement Award. Through the association, our professor has honored so many scientists by the award, by the name, by his own name, that is Dr. Gunasegaran Lifetime Award. He authored more than 14 books. Dr. Gunasegaran has awarded world ranking of top 2% scientist in the year 2021, which was published by Stanford University. He has been honored with Tamil Nadu Scientist Award, Dr. S. Morgan Lifetime Achievement Award, Best Citizen of Gold Medal Award, Indo Global Research Excellence Award, Lifetime Achievement Award by National College and University of Madras, and Best Teacher Award, Eminent Scientist Award, Certificate of Appreciation by Spectrochemica Actor in the year 2007, Tanza Award in the year 2013. It is very evident that from the humble beginning of our eminent professor, Dr. Gunasegaran, has come long a way, achieving all that he has. And if he stands tall today, it is only all through the sheer dint of hard work, honesty, sincerity, perseverance, and the self-confidence. I would like to quote a famous quote of APJ Abdul Kalam: dream, 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 convert the dream into thoughts and thoughts into action. கனவு காணுங்கள், கனவுகளை எண்ணங்களாக மாற்றுங்கள், அந்த எண்ணங்களுக்கு செயலாக்கம் தாருங்கள் என்ற வரிகளுக்கு ஏற்ப உங்கள் எண்ணங்கள் அனைத்தையும் செயலாக்கம் தந்து புதுவிதமான ஒரு நிறமாலை மாளிகையை இந்த ஒரு இயற்பியல் உலகத்திற்கு அறிமுகப்படுத்தி விட்டீர்கள். So, with that being said, let us call upon our eminent professor on the dais. Yes, professor, we welcome you wholeheartedly. Thank you, sir.
Respected Chairperson, Professor Dr. Dayamalai. I think always nominated Tamil professor for the chairperson of the session. I'm feeling Tamil professor. I'm happy. This is a government institution. That's it. And Dr. D. Kumar, the founder, Research and Development Director, and Dr. Ramesh Babu, Dr. Karnavaran, faculty members. Really, I'm thankful to the organizers for having given me this wonderful opportunity to speak to you on this somewhat interesting topic. ATR technique, we are fortunate to FTIR spectroscopy. Simple as well. You are all more familiar with the Fourier transform infrared spectroscopy, conventional spectrophotometer. This is not our duty now. The main agenda is I am going to predict what are the influences of the ATR technique, reflectant technique, attenuated, total, reflectant technique, which is embedded with the ATR spectrophotometer. That's it. I think this thing you studied long before during your school education. நீங்க 8வது படிக்கிறப்ப படிச்சிருப்பீங்க டோட்டல் இன்டர்னல் ரிஃப்ளெக்ஷன். அந்த டோட்டல் இன்டர்னல் ரிஃப்ளெக்ஷன் கான்செப்ட் அந்த மெயின் ஆப்ரேட்டிங் அந்த டோட்டல் இன்டர்னல் ரிஃப்ளெக்ஷன் கான்செப்ட் இன்க்ளூடட் இன் த FTIR spectrophotometer. What are the influences of this ATR technique in FTIR spectroscopy? That is a main agenda for the present topic. Dear friends, see the word spectroscopy. Colorful word. Beautiful subject. It is a core paper included in both UG and PG program, not only the physical science, also chemical science. Not optional paper, core paper, compulsory paper. Beautiful subject. And wonderful research area for materials characterization. That is important. The spectroscopy சொன்ன உடனே நம்ம ஞாபகம் வர்றது யாருங்க? You are really fortunate. The landmark in the history of Tamil Nadu, the landmark in the history of India, history of Tamil Nadu is the birthplace of Sir C. Raman. மறக்க முடியுமா? திருச்சிராப்பள்ளி, பக்கத்துல காவிரி ரிவர், அது பக்கத்துல ஸ்ரீரங்கம், அது பக்கத்துல திருவானைக்காவல், அங்கதான் பிறந்தார். So the landmark in the history of Tamil Nadu is the birthplace of Sir C. Raman. He is the first person received Nobel Prize in Science from Asian country. That is important. ஒரே ஒரு என்ன வருத்தம் என்னன்னா, நம்ம scientist, he invented Raman effect on 28 February 1928, for which he got the Nobel Prize in the year 1930. இல்ல எந்த அளவுக்கு பெருமை. Just by getting a sum of rupees, only 250 rupees from Birla industrialist, he was able to fabricate Raman spectrophotometer. Cost is only 250 rupees by his own. Collecting the raw material from India, he was able to fabricate Raman spectrophotometer without getting any things from abroad. The Indianness. This is the theme of this year National Scientist Celebration. நம்மால் கொடுக்கப்பட்ட கண்டுபிடிப்புகள் நமக்கு பயனடையும். Important. But என்னன்னா, just by spending 250 rupees, you are able to fabricate Raman spectrophotometer, Raman spectroscopy, Fourier transform Raman spectroscopy, laser Raman spectroscopy, resonance Raman spectroscopy, coherence anti-shock Raman spectroscopy, remote sensing Raman spectroscopy, etc., etc. That is, these are all what the revolution of the Raman spectroscopy. But at present, we are importing the instrument Raman spectrophotometer from abroad by spending more than 1 crore or 60 lakhs, 70 lakhs, depending upon the additional accessories. 750 ரூபாய் செலவு பண்ணி நம்மளே பண்ண அந்த இன்ஸ்ட்ருமெண்ட், we are not in the position to fabricate that instrument in India, but we are importing by spending crore from abroad. This is the status of the present Indian scientific community. தெரியும், நான் சப்ஜெக்ட் என்டர் ஆகிறதுக்கு முந்தி ஜஸ்ட் ஒரு 5 minutes என்னுடைய தாத்தா பத்தி பேசிதாகும். ஒரு ஷாக் ஆகாதீங்க.
Sir C. Raman is my grandfather. Academic grandfather. Not the bloodless சம்மந்தம் இல்லை. ஏன்னா அவர் ஐயங்காரன்றாங்க, வெள்ளையா இருப்பாரு, இவ்வளவு கருப்பா நிக்கிறன்னு நினைக்காதீங்க. அகாடமிக் கிராண்ட் ஃபாதர். பகவந்தம். You only fabricated the Michelson interferometer for MSc physics student. படிச்சிருக்கோம் நம்ம. ஆந்திரா யூனிவர்சிட்டி ப்ரொஃபஸர் ஹெட் பிசிக்ஸ், ஸ்டூடெண்ட் ஆஃப் சர் சி ராமன். பகவந்த ஸ்டூடெண்ட். அவரு ஸ்டூடெண்ட் வெங்கடேஸ்வரல். வெங்கடேஸ்வரல் ஸ்ரீராம சம்பந்தம். ஸ்டூடெண்ட்ல ஸ்ரீராம சம்பந்தம் மை கைட் டாக்டர் மோகன். அவருக்கு ஸ்டூடெண்ட் தான் நானு. அதான் சொல்ற கிளைம் பண்றேன். அகாடமிக் கிராண்ட் ஃபாதர். அவரை பத்தி ஒரு 5 நிமிஷம் பேசுறது I can enter into the present agenda better. It is my bound duty. The great personality, Sir C. Raman. He was very brilliant from the very start. அதாவது அவருடைய நாலேஜை பொறுத்து he got promotion for the maximum 5 years during his school education. அதாவது he has completed his matriculation at the age of 17 years, not at the age of 12 years, not 17 years. நீ பிளஸ் 2 முடிச்சிருப்பீங்க இல்லையா? முடிக்கும் வயசு என்னங்க? 17 வயசு. ஆனா ராமன் என்ன பண்ணார் தெரியல? 12 இயர்ஸ்ல முடிச்சிருக்காரு மெட்ரிகுலேஷன். அந்த ஏஜ்ல 10 வருஷம் 5 வருஷம் முந்தி குட்டி பையனா உட்காந்துட்டு இருக்காரு கிளாஸ்ல. எனக்கு என்ன சந்தோஷம்னா, I did my BSc physics in Tamil medium Presidency College. எந்த ரூம் நம்பர்ல சர் சி ராமன் உட்கார்ந்து படிச்சாரு BA ஆனர்ஸ், BA பிசிக்ஸ், அதே ரூம்ல உட்கார்ந்து நான் BA பிசிக்ஸ் படிச்சேன். அதான் எனக்கு கொடுப்பணும். அதே எனக்கு பெருமையா இருக்கு. அவர் உட்கார்ந்து படிச்ச ரூம் உட்கார்ந்து படிக்கிறதுக்கே எனக்கு பெருமைன்னா வேற என்ன பெருமை சொல்ல முடியும்? He got admission for first BA physics. அப்பெல்லாம் BA தான், BSல இல்ல. எல்லா ஸ்டூடெண்ட்ஸும் 30 ஸ்ட்ரென்த், கிளாஸ் ஸ்ட்ரென்த். எல்லா ஏஜ் 17 வருஷம். இந்த பையன் மட்டும் 12 வருஷம் தான். He was present in the first row. தலப்பா கட்டிட்டு குட்டி பையனா உட்கார்ந்துட்டு இருக்காரு. ப்ரொஃபசர் E.S. எலியட். எப்பெல்லாம் அந்த காலத்துல ப்ரொஃபசர்லாம் பாத்தீங்கன்னா பிரசிடென்சி காலேஜ்ல, மாநில கல்லூரியில மதராஸ் ஸ்டேட்ல இருக்க மாட்டாங்க. பீப்புள் ஃப்ரம் லண்டன் தான் இருப்பாங்க. ப்ரொஃபசர் E.H. எலியட், ப்ரொஃபசர் ஆஃப் இங்கிலீஷ். கிளாஸ் என்டர் ஆகிறார். பார்த்தவொடனே பையனை பார்த்தவொடனே அஸ்டானிஷ்ட். பையன் ஏதோ தப்பா ஸ்கூல் போற போய் இங்க வந்துட்டான்னு நினைச்சிட்டு, தம்பிங்க வா, வாட்ஸ் யுவர் நேம், வாட்ஸ் யுவர் ஃபாதர்ஸ் நேம், and how old are you, why you come here? So these are the questions raised by Professor E.H. Eliot. அந்த பையன் பயப்படலையே, நேரா போனோம். சார், மை நேம் இஸ் வெங்கட்ராமன். My father name is Chandrasekhar Iyer. My father is mathematics cum physics professor. I am 12 years old. Today I got admission for first BA physics. He is a brainy student. இதோட என்னன்னா, he got promotion for B honors. இப்போ MSc படிக்கிறீங்கல்ல, அந்த காலத்து B honorsனா MSc அர்த்தம். He got permission from then HOD, Professor John. All the British people now. To avail the small optical systems available in the physics laboratory to do some research. Research concept illa. Madras state la research concept illa. Appo guiding la illa. MSc project ku neenga guide doikku poringa varinga illaya. Naan guide fix pandrom, guide problem varadu work pandreen. His own interest, he got permission from Professor John to use the facilities available in the physics laboratory. He made some basic measurements. With that, he was able to publish 2 research articles. One was surface tension. Innor article on the diffraction and straightedge. These 2 papers were published in reputed journal, that is Philosophical Magazine, Journal of Science, London. இதுதான் பாயிண்ட். இந்த 2 பேப்பரும் பார்த்து நோபல் பிரைஸ் வாங்கின ஒரு பெரிய சயின்டிஸ்ட் by name Raleigh, he wrote letter to Presidency College. என்ன எழுதுனா தெரியுங்களா? Dear Professor Raman. இந்த டைட்டில் போட்டோன்னே கீழே ஆத்தர் நேம் போடுவாங்க இல்லையா? C.V. Raman போட்டிருக்கோம். Dear Professor Raman. எந்த அளவுக்கு குவாலிட்டி இருந்ததுன்னா, The paper should be written by a leading scientist or professor in the department. Assumption la he wrote letter to Professor College, dear Professor Raman, my dear young budding scientist. These two papers laid a strong foundation to him to do research in the years to come in different areas. அந்த ஒரு பேப்பர், ரெண்டு பேப்பர் தான் ஸ்ட்ராங் ஃபவுண்டேஷன் அமைஞ்சது. இந்தியன் அசோசியேஷன் ஆஃப் கல்டிவேஷன் ஆஃப் சயின்ஸ் கல்கட்டா, in which he worked for about 1 decade. He invented Raman effect, Raman scattering, Raman spectroscopy. And the organization, they have published 6 volumes of his research articles. You பாருங்க, that is scattering of light, acoustics, optics of minerals and diamonds, physics of crystals, floral colors and visual perception. See the different areas. சின்ன வயசுல. Dear friends, அதை விட என்னன்னா, after the invention of Raman effect, this organization, in the organization, National Council for Science and Technology Communication, Delhi, they have given the proposal to then Prime Minister Rajiv Gandhi to celebrate, to remark the invention of Raman effect. We have to celebrate National Science Day. You know, we are celebrating National Science on 28th February every year. Rajiv Gandhi accepted. Since then, from 1986, we are celebrating National Science Day in our country. Important. My dear friends, என்ன ஒரு வருத்தம்னா, just 1 year before, Dr. Karunakaran knows better. I had been to Jamal Mohd College, Tiruchirappalli, to inaugurate one international conference in the college. And அது 1 day முடிச்ச உடனே, along with my PhD scholar, I went to திருவானைக்காவல். ஒரு கேப் புக் பண்ணி போய் பார்த்தோம். அவர் பிறந்த வீடு திருவானைக்காவல்ன்றாங்களே, வீடு போய் பார்ப்போம். கவர்மெண்ட் ஆஃப் தமிழ்நாடு அவர் வீடை வாங்கி ஒரு நினைவல்லமா மாத்திருப்பாங்க, ஒரு ஆசையா போனாங்க. மை டியர் ஃப்ரெண்ட்ஸ், அவரு பிறந்து வளர்ந்த வீடு பக்கத்திலேயே வந்து 1 hour தேடுறோம், யாருக்குமே தெரியல. சரசிராமன் வீடு திருவானைக்காவல் கோயில் காம்பவுண்ட் பக்கத்துல தான் இருக்குது. ஒரு அம்மா கேட்கிறோம், வயசானமா உட்காந்துட்டு இருக்காங்க வாயப்பேடுல. அம்மா, விச் இஸ் த பர்த் பிளேஸ் ஆஃப் சரசிராமன்? ராமன் வந்தாருங்க, அவர் வீடு பார்க்கணும்னு கேட்கிறேன். என்ன சொன்னாங்க தெரியுங்களா? இல்லையா, போன வாரம் அவர் இங்கதான் இருந்தாரு, வேற வீடு வாடகை பார்த்து போயிட்டார். அந்த அளவுக்கு ஃபெமிலியாரிட்டியில பாருங்க. This is the status of the Indian scientific community. ஸோ கடைசியில் வந்து வித் கிரேட் டிஃபிகல்ட்டி நான் வந்து வீடே போய் போயிட்டு பாருங்க, அலாங் வித் மை ஸ்காலர் போய் பார்த்துருக்கு பாருங்க. ஒரு ஸ்மால் ஹட் மாரி இருக்கு பாருங்க, 3 ரூம் இருக்கு, வாடகை விட்டுருக்காங்க. நாட் ஓன்டு பை த மெம்பர்ஸ் ஆஃப் த சி ராமன் ஃபேமிலி, தேர்ட் பார்ட்டிக்கு சேல் பண்ணிட்டு வாடகை விட்டுருக்காங்க. சின்ன மை டியர் ஃப்ரெண்ட்ஸ், அவர் பெயரில் ஒரு பல்கலைக்கழகம் இருக்கா நம்ம தமிழ்நாட்டில். பர்த் பிளேஸ் ஆஃப் சரசிராமன், திருவானைக்காவல், தமிழ்நாடு. அவர் கண்டுபிடித்த ராமன் எஃபெக்ட், இஸ் தி ஃபாதர் ஆஃப் இந்தியன் சயின்ஸ். உலகம் ஃபுல்லா பயன்படுத்தப்படுகிறது. மோஸ்ட் ஆஃப் த லீடிங் ரிசர்ச் லேபரேட்டரி இன் தி வேர்ல்ட் தே ஆர் யூசிங் ராமன் ஸ்பெக்ட்ரோஸ்கோபி ஃபார் மெட்டீரியல் கேரக்டரைசேஷன். அந்த அளவுக்கு பெருமை தகுந்த தந்தை நம்ம சசி ராமன். அவர் பிறந்த மண்ணில், அவர் பெயரில் ஒரு பல்கலைக்கழகம் இல்லை. யோசிக்கணும், நம்ம தான் யோசிக்கணும். இப்படி என்னன்னா, there is one quote, aroma of flowers goes along with the wind. ஒரு பூவுக்கு வாசனை வந்து காற்று அடிக்கிற திசை தான் போகும். But the fame of a scientist goes even against the wind. That's all. He is a good example for this very good saying. நம்ம வந்து அவர் பிறந்த மண்ணில் ஒரு மதிப்பு தரலாம் கூட, உலக அளவில் அண்ட் அவர் ஸ்பெக்ட்ரோஸ்கோபி, ராமன் ஸ்பெக்ட்ரோஸ்கோபி plays a vital role for material characterization. Therefore, my dear friends, so following the footprints of Sir C. Raman, my dear friends, again I am telling, showcase your brain management, showcase your human resource management like Sir C. Raman. Showcase your time management to provide quality education, quality research in your higher education institution. With these few words, let us turn our attention to the present agenda. ATR technique, a patch into FTIR spectroscopy. The simple and the lovely one, don't worry. You see, so this is the slide, and the entire cross section of the electromagnetic spectrum is shown here, starting from radio frequency up to gamma ray, along with range of frequencies and wavelength. You see, shorter wavelength will have the higher frequency and hence higher energy. Longer wavelength will have the lower frequency and hence lower energy. That's all. The names of the different regions of the electromagnetic spectrum are classified based on the techniques employed for generation of the EM wave, for dispersion of the EM wave, and for detection of the EM wave. That's all. Another important thing is we are really fortunate. It's a nature's gift. Each and every region will have its own instrumentation technique for metallic cadentation. That's all. This is nature's gift. ஒவ்வொரு ரீஜன் சும்மா வெளில பாருங்க. ஒவ்வொரு ரீஜனுக்கு நம்ம என்ன பண்ணிருக்கோம்? We have invented ஒரு spectroscopy, electronic spectroscopy, vibration spectroscopy, NMR spectroscopy, and then ESR spectroscopy, X-ray, gamma ray spectroscopy, including ultraviolet visible spectroscopy. ஒவ்வொரு ரீஜனுக்கும் we have designed an instrument for metallic cadenation. We are really fortunate. This is a nature's gift. But here, our aim is we are going to give main focus on a very small part of the EM spectrum, that is the IR spectroscopy, ranging from 10 wave number to 12,500 wave number. This is the entire region of the IR region, infrared region. நீ சொல்லலாம், நீ சொன்னீங்களா சார், lambda nanometer சொன்னீங்க, frequency hertz சொன்னீங்க. But என்ன சொல்லிருக்கு பாருங்க, the range of IR spectroscopy is starting from 10 wave number, 10 centimeter minus inverse, and up to 12,500 centimeter inverse wave number. We are experiencing IR spectroscopy, Raman spectroscopy, in general, modular spectroscopy expressing wave number. You should know. You should know. Session முடிச்ச உடனே டவுட் இருந்தா கேளுங்க சொல்றேன். You see, ultraviolet visible spectroscopy nanometer, NMR nanometer, PLS nanometer. But we are experiencing the spectrum for modular spectroscopy with the Raman IR in terms of wave number 1 by centimeter. Why? You should know the reason. The reason we are getting spectrum is not, is meaningless. My dear friends, you see, what is spectroscopy? A spectral line is exhibited. Spectrum is nothing but interaction between the matter or material and the EM radiation. That's simple. Purplest. And a spectral line is exhibited when a molecule which is in the lowest energy level, I mean ground state, absorbs a quantum of energy h nu from the incident radiation, higher radiation, goes to excited state. This is okay. Absorption spectrum. A spectral line is exhibited when a molecule in the excited state emits a quantum of energy h nu and coming down to the lowest energy level. Anyway, emission or absorption, that's. இப்போ நம்ம நிறைய ஸ்பெக்ட்ரம் இருக்கு பாருங்க. I am going to give more focus on only vibrational transition, not electronic transition, not rotational transition. I am going to give only vibration transition. Transitions between the two vibration level within the same electronic level. That's all. will give the spectra in the infrared region, and which is called the IR spectroscopy or molecular spectroscopy or vibration spectroscopy. That's the basic definition. You see, simple method. Quantum mechanically, the vibrational energy, that is EV, which is expressed using this equation, small v plus half into h nu naught. Nu naught is the characteristics vibration, fundamental vibration, or internal vibration, normal modes of vibration. No difference. And the small v represents quantum numbers, takes the value 0, 1, 2, 3, almost equally spaced. That's. But I have mentioned already, energy is expressed in terms of wave number, not energy E. To get wave number, that should be divided by HC, E by HC. That is epsilon B is equal to nu naught by H is equal to, I think nu naught by C is equal to nu naught complement, that is a centimeter minus inverse. You are using SI unit or using MKS unit. But for vapor spectroscopy, we are using only CS unit. Why? That's the question. Express in centimeter only, not in meter. UV spectroscopy, nanometer, centimeter. 1 by CM use pandro, yeah, CM use pandro. This is the question to be raised. And you see, when V is equal to 0, lowest energy level, ground state, that's it. That is called the 0 point energy. That is nu naught complement divided by 2. The external radiation but the molecule of the materials in the ground state, which vibrates always. Radiation vibration. Without giving external radiation, even the molecule is the ground state, the molecules of the materials vibrate always. This is the concept. This is called the 0 point energy, ZPE. Okay. What is the condition for IR absorption? You take just a small level, there is a homonuclear diatomics. O2, oxygen. O, single bond, linear molecule. There is no charge difference. There is no dipole. Therefore, when IR is allowed to fall on this molecule, gets vibrated. During vibration, there won't be a change of dipole moment. Charge difference illa, dipole illa, appo dipole moment illa. Appo during vibration, there won't be a change of dipole moment. There is no dipole moment change. IR is inactive. This is a selection. You take second type of molecule, that is heteronuclear diatomics, HCl. Simple diatomic. Charge difference is there. Dipole present. Dipole moment present. In the process of irradiation, molecule gets vibrated. Therefore, there will be change in the dipole moment. Therefore, IR is active. So simple pathology. That is, IR is observable only for heteronuclear diatomics. Simple. This selection rule. Dear friends, you see, you are going to 8-year program. You must be more familiar with the complete block diagram of FTR spectrophotometer. Research is an organized knowledge. MSc particularly, you are studying not only physics, you are studying mathematics, you are studying electronics, and you are studying some chemistry also, applied. You are studying computer science. Why? So, to fabricate the spectrophotometer or any other analytical instrument, you must have the knowledge of all these subjects. Because research is organized knowledge. Knowledge of chemical science, physical science, mathematical science, electronic science, and computer science. All are embedded in this instrument. Silicon carbide, IR source. Silicon carbide, that is 50 millimeter length and 1 millimeter diameter, so 5 millimeter diameter. Synthesizing, that is a chemistry. And we are getting this one, interferometer, Michael's interferometer. Radiation is allowed to fall on the Michael's interferometer to get the complex wave. Time domain function. Time domain function. Michelson is the physical science, physics. Yes, you come over to ADC because this time domain function should be changed into frequency domain function in FTIR. They are applying the Fourier transform mathematical tool using high-speed computer. You see here the Fourier transform technique, the mathematical tool which is implemented by using high-speed computer, computer science, mathematical science. Our computer system will accept only digital data, not analog data. But the output of the Michelson is only digital analog data. Therefore, this has to be converted into digital data. Therefore, we are using ADC, analog to digital converter. That's all. That's why we are giving in our MSc physics curriculum, electronics, ADC, DAC, all படிக்கிறீங்க இல்லையா? சும்மா தரல. Then we are giving the time domain function to this input of the FT, and this FT circuit will convert the time domain into corresponding frequency domain. Before recording the IR spectrum of the sample under investigation, that should be changed into analog voltage. Again, we are going for DAC, digital to analog converter. This is a simplified block diagram for Fourier transform spectrophotometer, conventional spectrophotometer. Dear friends, you see, optical path diagram. This is called the sample compartment transmittance technique. Most of the laboratories in our country, they are having conventional FTIR spectrophotometer. They are using transmittance technique. We are going to introduce the reflecting technique in the place of the transmittance compartment by spending another 3 lakh rupees. For which are using total internal reflection. You have studied this concept in 8th standard science. Yeah. Okay. Main difference between transmittance technique and reflecting technique. That is, in the transmittance technique, IR spectral profile of a material can be obtained by means of transmitting the IR source to the sample. That's all. Follow up. In the case of reflecting technique, we are using only total internal reflection. Denser medium, rarer medium. That's all. But here, you see, because it has become more popular, because it compacts the most challenging aspects of IR analysis, namely sample preparation. Sampling is minimal, and accuracy is more. That's why the reflecting technique has become more popular nowadays. When I was doing my PhD in 1981 at MIT Chennai, Anna University, for one inorganic compound, I want to record IR spectrum. I went to IISc Bangalore. Inorganic physical chemistry, IPC. The conventional FTIR spectrophotometer. Enna pannalam theriyala? Grinding into a fine powder, given sample. Mixing with few drops of mineral oils. That's a multi technique. Multi technique. To create a paste. The paste is made between the two KBR windows. KBR is transparent to IR radiation. Why? KBR you must know the reason. Why you are using KBR window, which is transparent to IR radiation? KBR is nothing but crystal powder. Sir, Ramesh Babu, crystal powder. KBR, potassium, bromine. There won't be any bond formation. இது ஒரு அயான், that's all. தனியா நிற்கும் அவ்வளவுதான். பாண்ட் ஃபார்ம் எல்லாம் மாலிகுலர் ஆயிடும். பாண்ட் ஃபார்ம் ஆச்சுன்னா there will be change of dipole moment. ஹையர் அப்சர்ப்ஷன் கிடைக்கும். இங்க கே ஒரு அயான், பிஆர் அயான் பாண்ட் ஃபார்மேஷன் இல்ல. பாண்ட் ஃபார்ம் ஆகாத வரைக்கும் மாலிகுலே ஃபார்ம் ஆகல. That means there is no IR absorption. Therefore, KBr said to be transparent to IR radiation. ஒரு சாம்பிள் வைக்கிறதுக்கு ஒரு மேட்ரிக்ஸ் வேணுமா இல்லையா? அந்த மேட்ரிக்ஸ் தான் கேபிஆர் விண்டோ. 2 கேபிஆர் விண்டோ எடுத்து நீங்க அந்த பவுடரை அந்த டெஸ்ட் சாம்பிளை பவுடர் பண்ணி which is mixed with mineral oil, நிஜால் ஆயில், ஆர்கானிக் மெட்டீரியல் to create a paste. அந்த பேஸ்ட் எடுத்து போயிட்டு between the 2 KBr pelletல நம்ம வந்து விண்டோல வந்து ஸ்பேர் பண்றோம். And which is ready to be placed in the sample compartment for recording spectrum. இத வந்து ஓல்டுன்ட்டு ஒரு 50 வருஷம் முந்தி. என்ன பிரச்சனை தெரியுமா? அந்த மினரல் ஆயில் இருக்கு இல்லையா, நிஜால் ஆயில், ஒரு ஆர்கானிக். அந்த ஆர்கானிக் ஸ்பெக்ட்ரல் ஃபீச்சர் எல்லாம் பாருங்க. See, some strong bands at around 3000 wave number, symmetric CH stitching, asymmetric CH stitching இருக்கும், 4-5 பேண்ட் இருக்கு. Which corresponds to our நிஜால் ஆயில். நமக்கு தேவையில்லை. A strong band at around 1350, 1450 wave number, symmetric bending CH2, asymmetric bending CH2. அது நமக்கு தேவையில்லை. Outer plane deformation CH, which is found to be at around 720 இங்கே. So these are all the unnecessary band present because of multi technique, which give a lot of confusion to the assignment of the test material. அப்ப ரெக்கார்ட் பண்ண பிறகு இந்த பேண்ட மைனஸ் பண்ணிட்டு திங்க் பண்ணிட்டு நம்மள மைனஸ் பண்ணணும், ரிஜெக்ட் பண்ணணும், அசைன் பண்ணணும். unnecessary confusion is not accurate. This is the first method. Then nowadays, my dear friends, most of the laboratory you are having KBr pellet method, sampling method. Don't go for KBr pellet method. எதுக்கு வந்திருக்காங்க? You should use the ATR technique, not KBr technique. KBr யூஸ் பண்ணீங்கன்னா என்ன மெத்தட்? சாம்பிளிங் மெத்தட். You take 300 milligrams of KBr powder. You take 3 milligrams of your test material, mixing it and grinding to fine powder. Then which is placed or which is transferred to a barrel having a diameter 1.3 centimeter, which is placed on a pellet here by giving a suitable press at around 5 to 7 tons. Finally, we'll be getting glassy disc about 1 millimeter thickness, 1.3 centimeter diameter. That is a KBr pellet. இது எவ்வளவு டைம் செலவாகும் தெரியுமா? 25 minutes ஆகும். 25 minutes தேவைதானா? தேவையில்லாம ரெக்கார்ட் பண்றது ஒரு டைம் விடுங்க. Just sampling alone, we have to spend our precious time along the instrument, pellet instrument, for about 25 minutes. We are wasting our precious time. This is the problem. What are the issues surrounding the KBr pellet? First பாருங்க, complexity of the sample preparation. 300 milligram எடுக்கணும், 100 milligram போடணும், இவெல்லாம் மிக்ஸ் பண்ணணும். Physical balance யூஸ் பண்ணி ஆகணும், digital balance யூஸ் பண்ணி ஆகணும். And next பாருங்க, you see the preparation of the very messy, that is confusion. Time consuming, you are spending 25 minutes for sampling alone, not recording. And the fourth one is sample to matrix ratio. We can't expect equally. And the 1.3 diameter, 1 millimeter thickness on the KBr pellet, uniform sample இருக்காது. ஒரு இடத்துல அதிகமா இருக்கும், ஒரு கம்மியா இருக்கும். Suppose you are going for quantification, அப்போ it's not possible to ready quantification. For quantitative analysis, not possible with KBr pellet accurately. Next one, homogeneous throughout the sample, not possible because sample to matrix is not possible. Next one is matrix involved, materials involved are fragile. உள்ள கஷ்டப்பட்டு 20 minutes செலவு பண்ணி பிரஷர் கொடுத்து வெளியிடுக்கிறீங்க, KBr pellet ஒன்று நினைக்கிறீங்க, உடஞ்சி வரலாம். breakable. உடஞ்சி போச்சுன்னா போச்சு. You have to go for second time sampling. Another 25 minutes. And above all, very, very important thing, KBR powder is highly hydroscopic. KBR crystal, சாருக்கு தெரியும், very good absorber for water from moisture, air moisture. நீ என்ன சாம்பிள் எடுத்து பாருங்க. ஐஆர் பேண்ட் இருக்கு பாருங்க, 3600 வேவ் நம்பர்ல ஒரு பேண்ட் வரும். இது டியூ டு வாட்டர் மாய்ச்சர். 1600 பேண்ட் வரும் டியூ டு வாட்டர் பெண்டிங் வைப்ரேஷன், H2 பெண்டிங் வைப்ரேஷன். வாட்டர் பேண்ட் எல்லாமே இனிமே இருக்காது எந்த சாம்பிள் எடுத்தாலும். பட் கேபிஆர் பவுடர் வெரி குட் அப்சார்பர் பிகாஸ் ஆஃப் பர்மனன்ட் டைபோல் ஆஃப் த கேபிஆர் பவுடர். என்ன ஆகும் பாருங்க, எடுத்து பார்த்தீங்கன்னா ஸ்ட்ராங் வைப்ரேஷன் at around 3500 due to OH symmetric asymmetric stretching. Strong vibration at 1600 due to H2 bending vibration. In the strong vibration full which may affect the spectral feature of the test material. So these are all the 7 issues surrounding the KBR pellet technique. KBR pellet technique. This ATR technique addresses all these issues. point ATR technique, attenuated total reflectance technique. நீங்க FTR ஸ்பெக்ட்ரோஃபோட்டோமீட்டர் வாங்குறீங்கன்னா அதோ ATR வாங்கினா ஜஸ்ட் அது 12 லட்சமா, இது 3 லட்சம், அவ்வளவு பிடிச்சி போச்சு. Additional we have to spend minimum 3 lakh rupees for which you are applying the total internal reflection. You see, denser medium, this is a diamond crystal. What is mu value of 2.4. The refractive index of diamond is 2.4. So this is a sample or investigation, green shade. The sample வைக்கிறீங்க இல்லையா diamond crystal மேல, அது டெஸ்ட் மெட்டீரியல் under investigation. But என்ன கண்டிஷன்னா the mu value of the test material should be less than the mu of the diamond crystal. Then we can get the total interreflection. Important. You பாருங்க, you see angle of incident, this is a incident ray, that is a IR radiation. நீங்க IR radiation நேரா சாம்பிளுக்கு பதிலா through diamond crystal allow பண்ணீங்கன்னா diamond மேல நீங்க சாம்பிள் வைக்கிறீங்க. So IR radiation sent into the diamond crystal with an angle of theta that should be greater than critical angle. 8th standard science, எட்டாவது படிச்ச சயின்ஸ் புக் தான், வேற ஒண்ணுமே இல்லை. You are getting total internal reflection. This is a sample and a test, green shade. At the point of incidence, an evanescent wave is produced above the surface of the diamond into the sample. What is evanescent wave? IR bubble. இதான் கான்செப்ட். திங்க் பண்றான் பாருங்க. ஒரு பந்து எடுக்கிறீங்க வால்ல, போய் திரும்பி வருது, ஆங்கிள் ஆஃப் 5 அடிக்கிறீங்க, ஆங்கிள் ஆஃப் அதே 5 வந்து இந்த பக்கம் வருது, 6 வருது. பட் பாயிண்ட் ஆஃப் இன்சிடென்ஸ் இந்த வால்ல வந்து ஜர்க் வருது பாருங்க, வைப்ரேஷன் வரும் வால்ல. அந்த வைப்ரேஷன் மாதிரி ஐஆர் பபிள் வில் பி என்டரிங் டு த சாம்பிள். முக்கியம். திஸ் கால்ட் தி எவனசன்ட் வேவ். வந்து உள்ளே போயிடும் பெருசா. பட் ஹியர் யூ see, based on the change at dipole moment present of the molecular structure of the material under investigation, IR absorption takes place. Therefore, this IR bubble gets attenuated. This attenuated IR bubble is sent back to the reflected wave, which is sent back to the detector to get the IR spectrums. நீங்க சாம்பிள் வைக்கிறீங்க, within 32 seconds we can get the spectrum. அந்த KBR pellet 25 நிமிஷம் கழிச்சு, no need. You are saving 25 minutes for sampling alone. என்ன சாம்பிள் IR எடுக்கணுமோ IR வைக்கிறீங்க, within 32 seconds we can get the spectrum in our hand. Sampling is minimal. So this is the science involved in ATR technique. See, the same optical path diagram, the transparent compartment is replaced by this ATR accessory. This is a diamond crystal. That's all. The diamond crystal present நினைக்காதீங்க, 2 mm cross, 2 mm by 2 mm cross, கொஞ்சம் திக்னஸ் இருக்கும், அதுவே 3 லட்சம். டைமண்ட் ஆச்சு. ஸ்டூடெண்ட்ஸ் பார்க்குறப்போ கேர்ஃபுல்லா டீச்சர் அலோவ் பண்ணணும், வாட்ச் பண்ணணும். எது போயிட்டாலும்
synthetic diamond crystal. Synthetic diamond crystal.
No, sir. Because diamond is a more best to durability. Synthetic durability எதிர்பார்க்க முடியாது, ஸ்கிராச் ஆயிடும். அதான் மெயின். நெக்ஸ்ட் அந்த பாயிண்ட் தான் வராங்க. So here பாருங்க, you see what are the crystals being employed used in this ATRS set? சார் கேட்டாரு இல்லையா, டாக்டர் குமரன் கேட்டாரு இல்லையா, டைமண்ட் கிறிஸ்டல் தான் we prefer mostly. Best durability and chemical inertness. எந்த கெமிக்கல்ஸ் போட்டாலும் அது வந்து இராக்ட் பண்ணாது. எவ்வளவு தேய்ச்சாலும் நீங்க வந்து ஸ்கிராச் ஆகாது. ஸ்கிராச் ஆகி போச்சா we could not get the good quality spectrum. ஒரு நாளைக்கு 100 ஸ்பெக்ட்ரம் எடுப்பீங்க. ஒவ்வொரு ஸ்பெக்ட்ரம் ரீப்ளேஸ் பண்றப்போ கிளீன் பண்ணலாம் இல்லையா, கிளீனிங் வந்து யூசிங் டிஷ்யூ பேப்பர் பண்ணுவீங்க இல்லையா, ஸ்கிராச் ஆகும் இல்லையா, ஸ்கிராச் ஆக. Because of the best durability and chemical inertness, I think we prefer only diamond crystal. இங்க பாருங்க, you see zinc selenide, another crystal, silicon, germanium, we can go with the remaining 3 also. Least expensive, cost effective. சார் திங்க் பண்றாரு, டைமண்ட் கொடுத்தா 3 லட்சம் ஆகுது, சிலிக்கன் ஜிங்க் செலினைட் சிலிக்கன் ஜெர்மனியம் கொடுத்தா 50,000 போதுமே, இது போய் யூசிங் கேட்கலாட்டீங்க. பட் என்னன்னா, ஃபார் ஈச் அண்ட் எவ்ரி 2 months யூ ஹேவ் டு கோ ஃபார் ரீப்ளேஸ்மெண்ட் ஆஃப் த கிறிஸ்டல். ஒவ்வொரு சாம்பிள் நீங்க போட்டு கிளீன் பண்றீங்க இல்லையா, ஸ்கிராச் ஆயிடும், அப்போ ரீப்ளேஸ்மெண்ட் போகணும். ஸோ கன்சிடரிங் த ஹோல் லைஃப் டைம் ஆஃப் த இன்ஸ்ட்ருமெண்ட், you are going to replace the crystal several times. Considering the whole lifetime of the instrument, considering the replacement charge of the crystals like this, zinc selenide, silicon and germanium, our diamond crystal is cost effective. 20 வருஷம் யூஸ் பண்ற இன்ஸ்ட்ருமெண்ட் 20 வருஷம் ஒரே கிறிஸ்டல் தான், ஆனா 20 வருஷம் சூரிய கிறிஸ்டல் ரீப்ளேஸ் பண்ணணும், அது மேல போயிடும். ஓகே my friends, I am going to see how you can load the sample. Liquid sample, solid sample, and gaseous sample not possible. This is the only disadvantage. Okay, I am going to project some of the basic measurements undertaken by my PhD scholars in my laboratory. இவ்வளவு பண்ணது சொன்ன பிரயோஜனம் இல்லை. My dear friends, ஒரே ஒரு புத்தகம் written by late அருள்தாஸ், former professor of Trivandrum, Kerala University, spectroscopy, molecular structure எதிர்பார்ப்பாருங்க, படிக்கணும், நீ அழகா இது இருக்க. That's why he included his book as books for study, book for reference in the curriculum. கொடுத்துங்க பாருங்க syllabus. He has given all these aspects. After getting spectrum, and you should be more familiar with all these 22 parameters in your mind. What are the factors that affect the vibration spectra? On the title கொடுத்துருப்பார் பாருங்க. எங்கேயும் ரெஃபரன்ஸ் புக்லாம் ஹை லெவலில் போகல, அருள்தாஸ் கொடுத்த புக் தான் எடுத்திருக்கேன் நான். இப்போ எல்லாம் பி ஸ்டூடெண்ட்ஸ் அதிகமாக இருக்கீங்க, ரிசர்ச் ஸ்காலர்ஸ். நீங்கள் ஸ்பெக்டர் எடுத்த உடனே என்ன பண்ணுறீங்க, இதுக்கு முந்தைய அதே சாம்பிளுக்கு இன்னொரு பேப்பர் பப்ளிஷ் பண்ணியிருப்பாங்க, அதை ரெஃபர் பண்ண வேண்டியது, அப்படி கட் அண்ட் பேஸ்ட் பண்ண வேண்டியது, தப்பா வருது. ஒரு பேண்டுக்கோ ஒரு பாண்ட் ஆங்கிளுக்கோ இன்பிளேனோ அவுட் ஆஃப் பிளேனோ சிசரிங்கோ டிஸ்டிங்கோ வேகிங்கோ ராக்கிங் எது இருந்தாலும் சாம்பிளோட நேச்சர் பொறுத்து ஷிஃப்டிங் இருக்கும், அது தெரியணும் உனக்கு. அதே கான்ஸ்டன்டா வராது. கார்லேஷன் ஆஃப் த ஸ்பெக்ட்ரம் வந்து இம்பார்ட்டன்ட், ஃபார் விச் யூ மஸ்ட் பி மோர் ஃபெமிலியர் வித் all these 22 parameters, the factor that affect the vibration spectrum போட்டு கொடுத்திருக்காங்க பாருங்க. That is internal factors, atomic mass, then coupled vibrations, Fermi resonance, hydrogen bonding, then electronic effects, solid state effects for crystal material, side symmetry effects, correlation field effect, appearance of external mode, internal external mode coupling vibration, spectral line width, then physical state, temperature, concentration, solvent, symmetric asymmetric vibration, latent intensity, water combination, everything. இது தரவா இல்லைன்னா making assignment IR spectrum profile is not possible. நிறைய வந்து ஒரு நல்ல ஜேர்னல் எல்ஸ்டர் பப்ளிகேஷன் நான் பேப்பர் பார்க்குறேன், they have a very good reference system. இம்பேர் ஃபேக்டர் மோர் தென் 5 இருக்கு. ஆனா ஸ்பெக்ட்ரல் இன்டர்பிரேட் பண்ண தப்பா இருக்கு. ஸ்காலர் என்ன பண்றாருன்னா ப்ரீவியஸ் பேப்பர் அப்படியே கரெக்ட் பண்ண ப்ரீவியஸ் பேப்பர் தப்பா இருக்கு அசைன்மெண்ட் இங்கேயும் தப்பா இருக்கு. ரிவ்யூ பண்றது பார்க்கல, அப்படியே போயிட்டு இருக்கு. தப்பான இன்ஃபர்மேஷன் ரிப்பீட் ஆகிட்டே இருக்கு. After getting higher spectral profile of any material that you have synthesized, you must be more familiar with all these 22 factors. இந்த ஒரு ஸ்லைடுக்கு ஐ நீட் 1 hour. இப்ப முடியாது, தனி செஷன் வைக்கணும். இது தெரியணும். Kindly go through Aldas book pattern. Yeah, my dear friends, I am going to project some novel observations undertaken by my research scholars in my lab. In my lab, I have 3 instruments: FTR, ATR, invisible DRS and DTS, PLS. மூணு வச்சிருக்கேன் நான். மூணு சேர்ந்து காஸ்ட் அபவுட் only 50 lakhs தான். அவ்வளவு மீன். ஒரு நாள் என்னாச்சுன்னா, என்னுடைய PhD ஸ்காலர் without my knowledge, she went to my lab with honey sample obtained from supermarket, branded honey. ஒரு டிராப் போட்டு ஸ்பெக்ட்ரம் வந்துருச்சு. ஸ்பெக்ட்ரம் தப்பா வருது. ஓடி வருது, சார் the branded honey available in reliable source, supermarket எல்லாம் தான் வாங்கிட்டு இருக்காங்க. ஆனா வந்து which contain lot of water samples. எங்க வாட்டர் சாம்பிள் இருக்கும்? ஜீராகுது பாருங்க, வெள்ள ஜீராக தான் வாட்டர் சாம்பிள் இருக்கும். ரோட்ல வைக்கிறாங்க பாருங்க, குறிக்காருங்க. பக்கத்துல தேன் கூட வச்சிருப்பாங்க. போய் சொல்ல அர்த்தம். எப்ப தேன் கூடு பக்கத்துல வைக்கிறாங்களோ பிளஃபிங் அர்த்தம். இது மீனிங். வெள்ள ஜீராகுது பாருங்க, தேனா பாட்டில் வைப்பாங்க. அந்த ஜீராவில விச் கண்டெயின்ஸ் வாட்டர் கண்டென்ட் கரும்புச்சாறு தானே. நீ பாரு சார், ஜீரா தான் சார் அது. யூ சி a strong band at around 3500, broad band which may be due to H2O symmetric asymmetric stretching combined together presence of water. A band at around 1600 which is due to H2O bendy vibration. Water அதிகமா இருக்கு. எப்படி? My dear friends, honey sample, honey என்னங்க? Honey bee collecting nectar from flowers. அது சாப்பிட்டு டைஜஸ்ட் பண்ணது பாருங்க. டைஜஸ்ட் பண்ண வேஸ்ட் தான் வந்து ஹனி நம்ம சாப்பிடுறோம் இல்லையா? ஹனி பீ frequently used in by pharmaceutical industries. The drug design, drug எல்லாம் செய்யறாங்க இல்லையா? மெடிசின், டேப்லெட், இன்ஜெக்ஷன், they are using honey. Honey purity இல்லைன்னா we could not expect efficacy of the drug therapy. அப்ப இது மாதிரி பிராண்ட் ஹனி சொல்றப்போ இதுவே பொய்யா இருந்தா how we can expect drug therapy efficacy? I also shocked. இருந்தாலும் we are all molecular physicists. What are the active components of the honey sample? நமக்கு தெரியணுமா இல்லையா? அது தெரியாம நேராவது வாட்டர் சொல்லலாமா இல்லையா? அப்புறம் நெட் ப்ரௌஸ் பண்றோம். the main major component of honey is sucrose content. பாருங்க, sucrose content அப்பதான் you are molecular physicist. So what are the bonds present? What are the bond angles present? You must know. 3n-6 number of normal modes of vibration for non-linear molecule. 3n-5 number of modes of vibration for linear molecule. 2n-5 for bending vibration. n-1 stretching vibration. படிக்கிறீங்க இல்லையா நீங்க? இந்த ஸ்ட்ரக்சர் பார்த்தா தெரிஞ்சு பாருங்க. The active component present in honey sample is sucrose content. Sucrose content means which has many number of OH bonds. OH bonds. OH stretching வருமா இல்லையா? ஒரே ஒரு OH னா பரவாயில்ல, ஒரு stretching வரும். ஈக்குவல் OH அதிகமா இருந்துச்சுன்னா we can expect symmetric asymmetry. Deformation OH அத வரும். Because of number of OH bonds present in the sucrose content which is present in honey sample, we are getting this kind of broad band, strong band up to 3500, 1600. As a molecular physicist, you must be thorough with the components present in the material. Important. Dear friends, you see, we have software. A software பாருங்க. You see, pure honey red mark, கமர்ஷியல் அணி பெஸ்ட் இட் 99.57%. அது ரிசல்ட் கொடுத்துட்டு பாருங்க, பெஸ்ட் இட். நல்ல கம்பேரிஷன். So most of the pharmaceutical industries, they are having FTR ATR spectroscopy in their R&D laboratory to analyze the quality of the pharmaceutical formulations. ஒரு ட்ரக் டிசைன் பண்ண உடனே they are feeding the drug into the ATR machine, they are getting IR spectrum, they are able to analyze all kinds of vibration band assessment, quality superior. That's so role of R&D, role of ATR FTR spectroscopy by R&D department. Similarly, you see another interesting work. Sorry. Cotton, textile industry. இதுதான் ஒரு பாயிண்ட் சொல்ல போறேன். இப்போ கேபிஆர் பேலட் இருக்கு, பரவாயில்ல சார், ஏன் சார் 3 லட்சம் அதிகமாக செலவு பண்ண போறோம், எனக்கு கேபிஆர் போதும், 25 மினிட்ஸ் எக்ஸ்ட்ரா பரவாயில்ல, ஐ வாண்ட் டு ஸ்பெண்ட் 3 lakh rupees, எனக்கு FTR இன்ஸ்ட்ருமெண்ட்டே போதும்னு நினைக்கிறீங்க. சப்போஸ் ஐ வாண்ட் டு ரெக்கார்ட் IR profile of IR spectrum of fiber, IR spectrum of paper, IR spectrum of cotton. Is it possible with KBR? KBR பண்றது என்ன மெத்தடுங்க? ஃபைன் பவுடர் ஃபர்ஸ்ட் அரைக்கணும். Getting fine powder for cotton is not possible, impossible, not possible. Weird. But ATR diamond crystal அந்த துணி இருக்கு இல்லையா, I got the sample from Cooptex, கோயம்புத்தூர், தமிழ்நாடு. ஒரு ஒயிட் கர்ச்சீப் வாங்கி வாஷ் பண்ணிட்டேன், கஞ்சிலாம் இருக்கும், வாஷ் பண்ணி ட்ரை பண்ணி ஒரு கார்னர் மட்டும் அப்படியே டைமண்ட் கிறிஸ்டல் வச்சு we have pressure arm இருக்கு, ப்ரெஸ் பண்ணா I think we can get very good optical contact between the ATR diamond crystal and the cloth without having any air gap. Air gap வச்சா air spectrum வந்துடும். We are able to get the IR spectrum of our cotton. You see, இங்க இருக்கு பாருங்க, pure cotton and cotton cloth. இங்க கம்பேர் பண்றப்போ we are not getting the best fit, that is 87.97% வருது, some impure cotton. ஒரு டெக்ஸ்டைல் இண்டஸ்ட்ரியில குவாலிட்டி செக் பண்றோமா, இந்த டெக்ஸ்டைல் இண்டஸ்ட்ரி they have R&D laboratory in which they have ATR technique along with FTR spectroscopy. The role of ATR technique in R&D of textile industries on the application of product. And similarly, you see, organizers, they provide அந்த டைட்டில் ஆஃப் கான்ஃபரன்ஸ் பார்த்தீங்களா, என்வரான்மெண்ட் ஹெல்த். மேடம் இதுதான் ஆன்சர் பண்ணணும். அதாவது காயத்ரி மேடமும் ரவிச்சந்திரன் சேர்ந்து அழகாக காயின் பண்ணி நல்ல டைட்டில் என்வரான்மெண்ட் ஹெல்த்னு சொல்லிட்டு they are providing the hot drinks, beverages, tea, coffee in the paper cup. இது நியாயமா மேடம்? நீ பாருங்க, பிரச்சனை பாருங்க. அதாவது பேப்பர் கப் வாங்கணுங்க, பேப்பர் கப்புக்கு வந்து செல்லோஸ், பேப்பர் கப்பு we could not get the IR spectrum with KBR pellet, முடியாது, பவுடர் பண்ண முடியாது. பட் இட் இஸ் பாசிபிள் வித் ATR டெக்னிக். நாங்க அவுட்டர் எடுத்து பார்த்தா எனாமல் கோட்டிங் நாங்க எடுக்கல, அந்த எனாமல் கோட்டியுடைய ஸ்பெக்ட்ரம் ப்ரொஃபைல் வந்துடும். பாட்டம் எடுத்தா பாருங்க, getting almost பாருங்க cellulose spectrum cotton compared with the reference spectrum. And inner wall of the top paper cup பாத்தீங்களா, we are getting a spectrum like this. பாருங்க CH2 symmetric, CH2 asymmetric and CH2 bending, asymmetric bending 1375, 1450, out of plate deformation 722, which confirm the presence of polythene coating. Stiffness வரணும்ல மேடம், ஸ்டிஃப்னஸ் வரணும், லீக்கேஜ் ஆகக்கூடாது. ஜாயிண்ட்ல கோட்டிங் கொடுத்துட்டாங்க, என்ன பாலித்தீன் கோட்டிங் கொடுத்துருக்காங்க, அதான் கன்ஃபார்ம் ஆயிருக்கு. மெல்டிங் பாயிண்ட் ஆஃப் பாலித்தீன் கோட்டிங் இஸ் 105 degrees Celsius அவன் சொல்றான். ஆனா மெல்டிங் டேக் பிளேஸ் ஈவன் அட் 85 degrees Celsius. நீங்க கொடுத்த காஃபி 95 டிகிரி இருக்குன்னு நினைக்கிறேன். கொடுத்த காஃபில கஃபின் மட்டும் இருக்காது, கூட பாலித்தீன் சேர்ந்து வருது எங்களுக்கு. ஒரு நாளைக்கு 3 தடவை டீ சாப்பிட்றீங்கன்னா பேப்பர் கப்ல you are not only taking the caffeine content to get the stimulating effect for your body, also taking polythene coating harmful effect which poses health hazard. அதான் பேன் பண்ணாங்க. புரியுதுங்களா? So in this way ATI technique can be very employed in beverage departments. ஒரு டிபார்ட்மெண்ட் கொண்டு வராங்க. Similarly, you see, அப்பெல்லாம் பேஷனா போச்சு, வாழை கிடைக்கலையா, டோன்ட் வரி, யூ கோ ஃபார் பேப்பர் பனானா லீஃப் செயில். அது என்ன பண்றாங்க, கீழே பேப்பர் தாங்க, கீழே பாருங்க, கீழே வந்து பியூர் செல்லோஸ் தான், நோ ப்ராப்ளம். மேல பாருங்க பாலித்தீன் கோட்டிக்குது. பிச்சு போனீங்கன்னா பனானா லீஃப் பேர்ல ஒரு ஹோட்டல் இருக்கு, சாருக்கு தெரியும். அங்க போவாங்க, அங்க உண்மையா ப்ரீ பனானா தான் போடுவாங்க. ஹாட் ஃப்ரை சிக்கன், பிரான் எல்லாமே போடுவாங்க. அது பயங்கர சூடா போடுவாங்க. அது பரவாயில்ல. இஃப் யூ ப்ரொவைட் ஆல் தீஸ் ஃப்ரைட் சிக்கன், ஃப்ரைட் மட்டன் ஆர் ஃப்ரைட் ஃபிஷ் ஆன் த பேப்பர் பனானா லீஃப்னா பாருங்க, அப்படியே பாலித்தீன் கொட்டி ஒட்டி வரும். பட் டேக்கிங் நாட் ஒன்லி ப்ரோட்டீன் கண்டென்ட், ஆல் டேக்கிங் பாலித்தீன் கோட்டிங். These are the things to be noted. Interesting topic. We got the patent also. Thyroid, hypothyroid patient, mainly for women patient. குழந்தை இல்லாத பிரச்சனை இருக்குது பாருங்க. We got one seed taken from a plant which is available in Andhra Pradesh. Guglu seed. அது using GCMS we are able to get the active components, thyranoid components, responsible for cure the thyroid disease. Tablet with the help of one Ayurvedic medicine hospital at Tiruvallur nearby Chennai. Work பண்ணோம், we got the patent, காப்புரிமை வாங்கிட்டோம், GCMS. And we are able to analyze the thyroid patient tissues, not with the blood, my dear friends. Human hair, human nail, that's all. It is possible only with the ATI technique, not KBR pellet. Human hair powder பண்ண முடியுமா, ஹியூமன் நெயில பவுடர் பண்ண முடியுமா? பட் என்ன பண்ணா 150 ஹைப்போதைராய்டு பேஷண்ட் கலெக்ட் பண்ணி அவங்க கொடுத்தாங்க ஹாஸ்பிட்டல் வித் பர்மிஷன் எத்திக்கல் கமிட்டி. We got a piece of nail sample, full scalp hair. We record the IR spectrum of hair, IR spectrum of nail. அழகா இருக்குது. Before therapy, after therapy, during therapy பண்ணோம். அதுல வந்து மேக்ஸிமம் 90% ஆஃப் த பீப்புள் வந்து அழகா கியூர் ஆச்சு, கன்சீவ். இதை பேஸ் பண்ணி we got patent, ஜஸ்ட் 6 மாசம் வந்து பேட்டன்ட் காப்புரிமை வாங்கிட்டு. So IR spectroscopy along with ATI technique can be well employed in clinical laboratory to diagnose the diseases, not only with the blood sample, also with the human hair, human nail. Another interesting one. Okay. மேடம் முடிஞ்சு போச்சா? டைம் ஓவர் இல்லை, அதான் உட்காந்துருக்கு தெரியுது. எப்போது உட்காந்து போய் டைம் ஆயிடுச்சுன்னு அர்த்தம். இண்டிகேஷன் சிம்டம் முடிச்சிடலாம். ரமேஷ் பாபு இருக்காரு, அவர் ஒர்க் முடிச்சு கொடுத்துடலாம். இங்கதான் வந்து கிறிஸ்டல் மெட்டீரியல், கேடிபி கிறிஸ்டல் பாருங்க. We are entering into the unit cell. HTPO4 KDP crystal, potassium dihydrogen phosphate crystal. என்னன்னா solid state effects சொல்ல பாருங்க, 22 parameter ஒரு பெயின் இம்பார்ட்டன்ட் parameter. Solid state effectல because of the crystalline environment and the molecules alignment பார்த்தீங்கன்னா நீங்க symmetry is restricted. Symmetry of the molecule is restricted within the unit cell. Because of the symmetry restriction, non-degenerative vibration will be shifted. Splitting of degeneration vibration, activation of inactive bands, எல்லாமே புதுசாக தெரியும். குரூப் 3 இல்லைன்னா ஒன்றும் இல்லை. குரூப் 3 யாரும் படிச்சுக்க மாட்டேன்னு நினைக்கிறேன். We are removed the group 3 from syllabus நினைக்கிறேங்க. எனக்கு கஷ்டமாக டீச் பண்ணுறது பாத்தியர்களுக்கு. நம்ம நம்ம டீச்சர்ஸ் கஸ்டமர் டீச் பண்ணுறது குரூப் தியரி. we remove group theory in the mathematics physics paper and from physics. நான் டீச் பண்ண கஷ்டப்படுறாங்க. அதாங்க சரி, சிம்பிள் கான்செப்ட், வெரி இன்ட்ரெஸ்டிங் கான்செப்ட். வித்தவுட் குரூப் தியரி நோ வைப்ரேஷன் ஸ்பெக்ட்ரோஸ்கோபி இருக்கணும். சொன்னீங்க இல்லையா, டீஜெனரேட்டிவ் வைப்ரேஷன் சொன்னேன், நான் ஜெனரேட்டிவ் வைப்ரேஷன் சொன்னேங்க, ஆக்டிவிட்டி நெட் சொன்ன மாதிரி எல்லாமே குரூப் தியரி கேரக்டர் கொண்டு வரணும். நீங்க அப்ளிகேஷன் தெரியல. This is called the side symmetry effect. The correlation field effect. Because the interaction between the two molecules, between the two adjacent unit cell, or within the same unit cell, we are getting splitting of both degenerate species and generate species. The group theory there you then external mode, the translation mode then the rotation mode less than 600 wave number adu crystal la. Yeah. So crystal quality study பண்றதுனா using IR spectroscopy, you must be familiar with solid state effects, side symmetry effect, correlation field effect, external mode, coupling between internal external mode. That's all fact. Then only you can do a very good assignment to study the crystalline quality. Important. Dentistry அதுவும் யூஸ் பண்ணிருக்கோம். 5 நிமிஷம் முடிச்சிடலாம். டென்டிஸ்டி, பல்பி காம்போசிட், சில வந்து கேப் இருக்கும், அழகா ஃபில் பண்ணலாம். பல்பி காம்போசிட் அது டூத் பேஸ்ட் பேர் தெரியுங்க. By giving some kind of radiation for a particular time, the bulky composite become very hardness. அவருடைய மெக்கானிக்கல் ஸ்ட்ரென்த் ஆல்மோஸ்ட் ஈக்குவல் டு டென்டில் டூத் எராமல் அழகாக. So degree of conversion can be analyzed using IR spectroscopy very easily. Degree of composition, degree of conversion பாருங்க. எங்க லேப்ல பண்ணோம், டென்டிஸ்ட் வந்து ஹெல்ப் பண்ணாங்க. So we can make use of the ATI technique in the dentist department also. Last slide. I went to Pugalur, Tamil Nadu Newsprint Limited, quasi government of Tamil Nadu. They are making paper. Now ஒரு half a day செலவு பண்ணி how they are making paper என்றது எல்லாம் கொடுத்தாங்க. wood, நான் woody means தேக்கு மரம், சவுக்கு மரம். நான் wood means கரும்பு சக்கை. that's all. மிக்ஸ் பண்ணி கூழாக்குறாங்க, ப்ளீச் பண்றாங்க to remove lignin, only cellulose, அது ஒயிட்டா இருக்கும். அப்படி ப்ரௌன் கலர் போறதுக்கு வந்து ப்ளீச் பண்றாங்க, ஃபில்லிங் ஏஜென்ட் போடுறாங்க. எல்லாம் கத்துட்டு வந்துட்டு in my laboratory I assign a problem to one of my PhD scholar, nano cellulosic fiber. Cellulose study பண்றோம், paper baking, that is routine work. But you have synthesized nano cellulosic fiber, nano particle கொண்டு வந்தோம், for which we have found a crystallinity index CI by using two vibration frequencies around 980 torsional mode CH, 1450 asymmetric bending mode CH. That's all. Indirect level. The reference rate. You have got very good crystallinity. Using this nano cellulosic fiber, we have prepared a material that will be used as water purifier, contaminated with uranium content, radiation pollution nearby IGR Kalpak. இப்போ பேட்டன்ட் ஃபைல் பண்ணியிருக்கோம், will be getting grant shortly. Making a new material that will be used to purify the water which is contaminated with the uranium content in the sites of nearby IGR Kalpakam. இது வந்து other work. Therefore, my dear friends, last slide. ATR technique பொறுத்த வரைக்கும் ஒரே ஒரு எக்ஸாம்பிள். இது conclusion. That is neither accurate nor precise. It is the performance of a mark pen on a rifle range. Second one is precise but inaccurate. Third one is accurate but imprecise. Last one is precise and accurate. That's all. Therefore, ATR technique along with FTR spectroscopy, an extremely reliable technique and well-recognized technique. Hereafter, we can go for only FTR ATR spectroscopy. Don't use KBR pellet method, conventional spectroscopy. That is my humble request. Therefore, my dear friends, thank you.
Thank you very much, sir. It is an excellent speech. Dear students and dear scholars, if you have any doubt or any questions, you can share with our eminent professor.
To make the vibrational band assignments of your material using IR spectroscopy, we can refer the reference spectra which are available in the IR library. Netly, no problem. But என்னன்னா சப்போஸ் ஒரு கிறிஸ்டல் குரோ பண்றீங்க, சார் இப்போ குறிக்கோள் இருக்காரு, கேடிபிக்கல் குரோ பண்ணிட்டீங்க, அதில் H2PO4 பொட்டாசியம் டயஹைட்ரஜன் பாஸ்பேட் எடுத்துக்கங்க, பொட்டாசியம் அயான் தனியாக நிற்கும், பொட்டாசியம் கேவுக்கும் H2PO யூனிட்டுக்கு வந்து பாண்டே ஃபார்ம் ஆகாது, பாண்ட் இருக்கக்கூடாது. அப்போ H2PO4 தான் இருக்கு பாருங்க, POOH ரெண்டு H இருக்கு, OH இருக்கு. அப்போ ரெண்டு OH இருக்கு, என்ன பண்றாங்கன்னா OH touch vibration இருந்ததுன்னா ஈக்குவல் பாண்ட்ஸ் இருந்ததுன்னா we can think about symmetric OH, asymmetric OH. Symmetric OH may be at around 3400 wave number. Asymmetric would be 3600. ரெண்டும் ஸ்ட்ராங்கா மெர்ஜ் ஆகிறதால ப்ராடா வந்துடும் இல்லையா. என்ன பண்றேன்னா OH touch vibration 3500 தானே, அந்த ரீஜன் அசைன் பண்ணிடுறாங்க. இங்கதான் வந்து கிறிஸ்டல், அதாவது சாலிட் எஃபெக்ட் வருது பாருங்க. எப்படின்னா இங்க ஃபெர்மி ரெசோனன்ஸ் மட்டும் இல்லை, அதாவது கிறிஸ்டல் எஃபெக்ட் இருக்கு. தட் இஸ் என்னன்னா வந்து இன்னொன்று இம்பார்ட்டன்ட் திங் என்னன்னா, நாட் ஒன்லி ஃபெர்மி ரெசோனன்ஸ், ஹைட்ரஜன் பாண்டிங் டேக்ஸ் பிளேஸ். ஹைட்ரஜன் பாண்டிங் H நல்லா ஆகுது இல்லையா, ஹைட்ரஜன் பாண்டிங். அந்த 3600 வேவ் நம்பர் will be shifted towards lower wave number 2800 போகுது ஆக்சுவலா. Because hydrogen bonding takes place in H2PO4 ion, and the wave number which is present at 3600 will be shifting towards 2800 wave number. நம்ம என்ன பண்றோம், ரெஃபரன்ஸ்ல OH தான் இவ்வளவு இப்படி இருக்கும். ஆனா தட் இஸ் ஹைட்ரஜன் பாண்டிங் திங்க் பண்ணாம தப்பா அசைன் பண்றோம். ஒரு பேப்பர் தப்பா அசைன் பண்றதால அப்படியே எல்லாம் ஃபாலோ பண்றாங்களா, அப்படியே போகுது. இந்த ரெஃபரி சிஸ்டம் பார்க்க மாட்டாங்க, சரியா இப்படி போட்டுறாங்க. பண்ற ஒரு தப்பு அப்படியே கண்டினியூ ஆகுது பாருங்க. அதுதான் வந்து ரெஃபரன்ஸ் எடுங்க, ரெஃபரன்ஸ் எடுத்து பண்ணா அது என்ன தப்பு பிளஸ் மைனஸ் நீ பார்க்கணும் நீங்க. That's why you should be more familiar with all 22 factors that affect the vibration factor. அப்பதான் கரெக்டா அசைன்மெண்ட் பண்ண முடியும். For which experience is very important. எக்ஸ்பீரியன்ஸ் ஒன்றும் பண்ண முடியாது, பண்ணி அந்த இன்ஸ்ட்ருமெண்டோட நீ வாழணும்.
என்ன மாதிரி chemical shift like the hydrogen bonding, whether useful for some applications? In a chemical system,
yes, sir. Yes, sir.
The same way, even the presence of hydrogen bonding can be a fingerprint.
Definitely. In the case of hydrogen bonding,
Nice may be taken for.
Yeah. As far as hydrogen bonding is concerned, we can consider the only IR spectral profile. There are two kinds of hydrogen bonding. That is intermolecular, intramolecular.
Yes.
For intermolecular means sharp band will be very sharp.
Yes, sir.
For intermolecular means band will be very broad. Also constant and dependent. Very important. So instead of using our chemical shift in NMR, we can make use of IR spectroscopy better. We can accurately identify and hydrogen bonding, either intramolecular, intermolecular. Better, sir.
My MPhil thesis.
Nice. Interesting area. Hydrogen bonding. Hydrogen bonding nothing but defined the bond between atom B and H of a covalent bond AH to form a group AHB. That's all. Because of the hydrogen bonding, the AH bond will be moving towards lower frequency with the increase of band. Same. Very interesting field. Yes. எங்க வாத்தியார் தான் கேட்குறாங்க, பிஜி ஸ்டூடெண்ட்ஸ் பிஎஸ்க்கு யாரும் கேட்க மாட்டேறாங்க. புரிஞ்சு போச்சுன்னு அர்த்தம், இல்லாட்டி புரியலன்னு அர்த்தம். ஒன்று புரிஞ்சிருக்கணும், புரியாமல் இருக்கணும். ஆமாம், ரைட் சார்.
They are learning.
லேர்னிங் கரெக்ட்.
Process of learning.
கரெக்ட். இப்போ நான் ஒரு கொஸ்டின் சொன்னேன் பிகினிங்லே, ஒய் ஆர் யூசிங் வேவ் நம்பர், அது வந்து கேட்கவே இல்லை, மறந்துட்டேன். இப்போ டைம் எல்லாம் கூட டியூரிங் லஞ்ச் டைமும் கேளுங்க. எல்லாமே we are expressing the energy in terms of nanometer, எனர்ஜி சொல்றோம், ஈ சொல்றோம். ஆனா ஐஆர் ராமன் மட்டும் we are expressing in terms of wave number ஒய்ன்னு கேட்டேன். அதுவும் பேசாம தான் இருக்கீங்க நீங்க. கேளுங்க, எல்லாம் பசியா இருக்காங்க.
சரி,
சொல்லுங்க சார். கூகுள் சர்ச் கூட
Thank you, sir. I invite Dr. R. Anandi ma'am, Organizing Secretary, to honor the chairperson of this session, Dr. S. Devamalan ma'am. Thank you, ma'am. Next session, invited lecture 2. We are honored to have Dr. M. Karnagaran, Associate Professor, Alagappa Arts and Science University, Karaikudi. He has 18 years of teaching experience and he has published 132 papers in national and international awards with H index of 19 and I-10 index of 31. Awards received by him: Young Research Award 2021, Inspiring Research Supervisor Award 2021, Best Teacher Award 2022, Best Scientist Award 2022, Best Researcher Award 2023, delivered more than 56 invited talks, guided 5 PhD scholars, 15 MPhil students, and 36 MSc students, currently guiding 5 PhD scholars. Now, I would like to invite Dr. M. Karnagaran sir for the next session. Before that, I would like to invite Dr. Kesavan sir to honor the chairperson. Thank you, sir. Now, I would like to invite Dr. M. Karnagaran sir for the next session to introduce about our speaker.
Good afternoon, one and all present here. I thank the organizers,
for giving me to the wonderful opportunity. ஒரு கான்ஃபரன்ஸ் என்ன செய்யும் அப்படின்னு பார்த்தோம் அப்படின்னா, ஒரு கான்ஃபரன்ஸ் உடைய வேலை இன்வைட்டட் ஸ்பீக்கர்ஸ் பேசுறத கேட்கறது மட்டும் இல்ல, நிறைய இன்ஸ்டிடியூஷன்ல இருந்து வேற வேற இடத்துல இருந்து நம்ம மீட் பண்ணிருக்கோம், நிறைய கான்டாக்ட் கிரியேட் பண்ணும், நம்மளுடைய ரிசர்ச் அடுத்த கட்டத்துக்கு எடுத்துட்டு போறதுக்கு பயன்படும். இப்ப நான் உங்க முன்னாடி நிக்கிறேன் அப்படின்னா இதுக்கு ரீசன் என்ன அப்படின்னு பாத்தீங்கன்னா, நிறைய கான்ஃபரன்ஸ் அட்டன் பண்ணது, அந்த கான்ஃபரன்ஸ் வாயிலாக நிறைய பேரை சந்திக்கிறதுக்கு ஒரு வாய்ப்பு இருந்துச்சு. அந்த சந்திப்பு புதிய புதிய அறிவியல் கண்டுபிடிக்கிறதுக்கு பயனுள்ளதா இருந்தது. அந்த வகையில இப்ப இந்த கான்ஃபரன்ஸ்ல என்னுடைய வேலை நெக்ஸ்ட் ஸ்பீக்கர் இன்ட்ரோடியூஸ் பண்றது. Next speaker, Dr. R. Ramesh Babu. He is a highly respected scientist and academic leader, currently serving as the head of the Department of Physics at Bharatvasan University in Tiruchirappalli. He holds extensive expertise in crystal growth, thin film deposition, and nanomaterials. And his dedication to research is evident through his impressive achievements. His area of research is crystal growth, thin films, and nanomaterials. Recognition and awards are: he received the prestigious Tamil Nadu Young Scientist Award in 2018, honored as a Fellow of the Academy of Science, Chennai in 2018, holds membership in esteemed professional organizations like the Indian Association for Crystal Growth and Japan Society for Applied Physics. Beyond his research contribution, Dr. Ramesh Babu actively engages in various service activities like member of the CARE committee at Bharatvasan University, serves on the advisory committee of the Science and Technology Journal. Now I invite Dr. Ramesh Babu sir. Please sir.
Thank you, sir. Thank you for your nice introduction. Good afternoon, all present here. First of all, I would like to thank the organizer for having given this opportunity to present some of my research work in front of young minds. In this lecture, I am going to give idea about how we can grow a bulk single crystals using the simple techniques, particularly melt growth techniques for different applications. This is my plan of presentation. So, for the benefit of young students, first I will give brief introduction about crystals. For our research, we have chosen the organic materials to grow as a bulk single crystals, but particularly for NLO applications, non-linear optical applications. Then, the design and construction of vertical bridgement system, one of the melt growth techniques to grow a bulk single crystals. Then the growth of organic single crystals by vertical bridgement system. So our contributions in the melt growth techniques, we have designed the vertical dynamic gradient free systems, one of the unique system in India. So we have developed in our laboratory. So using that techniques also we have grown growth for organic materials. Then the characterization studies which we have carried out on the bronze crystals I will discuss. Finally summarize my lecture. So before going to discuss this growth of single crystals by melt growth techniques, some basics professor also discussed, that is the importance of crystals. So applications of these crystals. Even though we are in the era of nanotechnology, So for every applications we are saying nano. So for specific applications, we need a bulk single crystals. For example, for scintillator applications, even to produce the lasers, we need a bulk single crystals. So I can discuss one by one. In ancient days, you see these single crystals are crystals used to hunt the animals. Okay, so they made different shapes of these materials to hunt the animals like this. Then you see that, so these crystals, beauty and rarity of these crystals attract the mankind's, like a ruby, diamond, and other type of crystal materials used as ornamental purpose. Then mid of the previous century, so after the invention of, so before that, these crystals are also used for healing purpose. Healing purpose, particularly to heal the wounds. I don't know this one is working or not. So, but I found this slide from internet only. Actually, these crystals they are selling for anchor management. Okay, so previously this is the magical crystals used to heal the wounds. Then you see the நம்ம தெரியும் நம்ம தாயத்துன்னு நம்ம கட்டுவோம் இல்லையா, so that contains the crystal materials without knowing the science and that one, so we are these things. Yes, you see after the invention of piezoelectric effect, we know that what is piezoelectric effect. When you supply a force to any materials, that can generate EMF. Okay, so vice versa. So if you apply any EMF to this material, crystal materials, that make a vibrations. Okay, so this is the inverse piezoelectric effect. With this concept, you see these crystals used in our watches. Okay, so backside of that watch we can find very many parts, like you see stepping motor, electronic components, mechanical components, battery and quartz crystal also. Okay, so here you see that after the growth of these crystals, it makes like a shaped quartz element, then it is, so they can make like this and then placed at this part. Okay, so with this mechanism of piezoelectric effect, so we are using, without knowing the applications of these quartz crystals, we are wearing these watches in our hand. Okay, before the mid of the previous century, you see after the invention of silicon for transistor applications, the silicon materials used in very many applications. For example, for semiconductor detectors, as well as for SAW devices, surface acoustic wave devices, so as well as for second harmonic generators. So this is the element of second harmonic generators. These crystals used to found a new laser materials or new wavelengths. Like you see that this is the red laser. Using that one, we can convert this red into the green lasers. This is the applications of the single crystals. Now, in current scenario, these crystals used in solar cell applications. We all know even though the scientists we are involving the production of fourth generation of or third generation of solar cell devices using different type of materials. The entire solar cell industry owned by only one material, that is called silicon single crystals. Okay, because that silicon single crystals that shows very high efficiency as well as a stability, high stability. So this is the growth of silicon single crystals by Joukowski technique. You see, so these silicon wafers installed as a solar cell devices in order to convert the light energy into the electrical energy. These crystals used in very many applications in medicines as well as the material science for laser cutting, as well as even though we can uh, derive very many information from satellite. In order to run the satellite, it needs powers. There only the solar cell devices, so our solar wafers, crystal wafers used as here, okay, to convert the light energy into the electrical energy. Okay. So this is the photographs gives beautiful crystal materials. This all the three materials is nature grown single crystals: snow, quartz, and NaCl. So all these one bottom one, that is KDP, potassium dihydrogen orthophosphate, lithium borate, and ruby. So grown by different synthetic techniques, like, so these type of single crystals we can derive from our mother earth in the ancient days, but after the invention of like diamonds, ruby, quartz, we can get from our mother earth. So but after the invention of very many transistors as well as the piezoelectric effect, so the in order to satisfy the needs of electronic industry, we need more number of crystals. So for that, the scientists involved to grow to identify new crystal growth methods. Then only you see this crystal growth methods established by different scientists. Like, so any method, so in order to grow a crystals, it needs control of phase change or phase transformations. So it may be a liquid to solid transformation or vapor to solid transformation or solid to solid phase transformations. By means of phase transformation only, so they have named crystal growth techniques like solution growth, melt growth, and then vapor growth techniques. Okay, any technique, it may be a vapor growth or solution growth or melt growth techniques, you can choose to grow a single crystals, but you have to follow three important steps. One, so you need to achieve or attain the supersaturation, then only we can get a nucleation in that solution or melt or vapor. So finally we can grow a bulk crystal growth. So without supersaturation, definitely we cannot expect this nuclei in the solution or melt or vapor. Okay, so we all know the matter exists in four form depending upon the atomic arrangements. So we classified this one. So this crystals comes under the category of solid category. Okay, solid further classified into crystalline and amorphous materials. Crystalline material further classified into polycrystalline and single crystalline materials. If the arrangement of atoms in three-dimensional or repetitive patterns in a long range order, for example 10 to the power of 23 atoms arranged in a without any discontinuity, means that is called single crystals. Suppose that arrangement, that periodic arrangement is in short range order, that is, that also contains the grain boundary, means that is polycrystalline materials. For very many device applications, the single crystals used. I can give you the best example. So the scientists, they are producing silicon materials using single crystalline silicon, polycrystalline silicon and amorphous silicons. All these type of materials used for solar cell applications. But these single crystalline based materials shows very high efficiency than that of that amorphous as well as the polycrystalline. Why do we need single crystals? Yes, you see that this the physical properties of any materials, that decided by internal symmetry of that materials, so therefore when you take that polycrystalline materials, that contains the grain boundaries, these grain boundaries acts like a defect centers that deteriorates the properties of materials. Therefore the internal symmetry in that single crystal is somewhat better than the polycrystalline and amorphous materials. Therefore these single crystals used in very many applications, device applications. So single crystals are occurred due to the superior long-term orientation, high packing density, large macroscopic nonlinearity, as well as that can shows that is optical quality is very high. So for our case, so we have chosen the organic materials to grow as a bulk single crystals by melt grow techniques. So for nonlinear optical applications. Nonlinear means here you see that these nonlinear optical materials are the materials in which the dielectric polarization responds non-linearly, not in the with respect to electric field. This polarization, suppose in the linear one, means that is the dielectric materials that shows the response non-linearly to the electric field, means with respect to intense light, means that is called non-linear optical materials. This type of non-linear optical materials, so that it has the superior properties. Using this one, we can produce or achieve the desired laser frequency, as well as these materials used in frequency conversion and mixing applications, electro-optic modulation, optical parametric oscillation applications. Even we can also that playing an important role in generating the green and blue lasers. How we can achieve this NLO properties in material means this NLO response we can get from this polarizability of materials. So that contributions, so from lattice components, that is atoms or molecules, or otherwise interaction between these two atoms and molecules also may contribute for this polarizability of that materials. So in organic materials, the first contributions dominant one, whereas in the inorganic type of materials, the second contribution, that is the interaction between the lattice components, atoms and molecules, play a vital role for polarization mechanisms. This organic type of materials, that it has the superior properties, that is why we have chosen for this problem. One is larger, that has the larger nonlinearities than inorganic type of materials, ultra fast response time, high damage threshold, so in very high lasers, as well as the high molecular polarizability, and then pi electron conjugated molecules. One more important properties, that is the tolerability on structures. When compared to inorganic materials, we can change the structures or modify the structures in easy way for this organic materials when compared to inorganic one. So therefore the scientists, they have taken very many efforts to grow a bulk single crystals of these organic materials using the solution, melt and vapor growth techniques for nonlinear optical applications. But growing bulk single crystals of these organic materials is a very challenging one for crystal growers, because these materials that has thermal and chemical instability. So we need to optimize this thermal and chemical properties. Then only we can grow as a bulk single crystals, particularly by melt growth techniques. That is that challenge we have taken to grow as a bulk single crystals. We can grow these organic materials by solution, melt and vapor growth techniques. But so all these techniques that need high pure starting materials. So because this, when you use impure materials, definitely that reflect the efficiency of the device. Okay, so therefore we need high pure starting materials. Then we need thermal and chemical stability data of that materials. Without this one, so we cannot enter into the growth techniques. Why we have chosen this melt growth techniques particularly? You see that while using this solution method, so we can grow a crystals with slow growth rate, so less than 0.1 mm. Then solvent inclusion, sometimes solvent, so our aim to grow, for example, our aim to grow KDP single crystal, potassium dihydrogen orthophosphate single crystals, using the solvent of water. Sometimes this water molecule can enter into the KDP, so that give final product like a KDP monohydrate. So that is not useful one for our case. So this sometimes we can enter while using the solution growth, we can encounter the solvent inclusion problem. Then while using this vapor growth techniques, we need to identify the low vapor pressure material with low vapor pressure, as well as these materials give the crystals with low growth rates, very low growth rates. And then this method is not effective to grow a bulk single crystals. It can give the very high quality crystals, vapor growth techniques, but we need a bulk single crystals for different applications. That is why we have chosen this melt techniques. This method is convenient as fast techniques. We can grow even one day, 3 days, we can complete the very big single crystals we can grow by this melt growth techniques. So what kind of materials we can use to grow by this melt growth techniques means materials which melt without decomposition, can be cooled from freezing temperature to room temperature without fracture or phase transformation. We can select this type of material to grow as a bulk single crystal. Suppose a material encounter the decomposition before melting means that is not possible to grow by this technique. That is the important one. Almost you see that 80% of single crystals what we are going to use only grown by this melt growth techniques, particularly this Bridgman and Jokralski technique. These two, Bridgman and Jokralski, they are the scientist named after techniques like a Bridgman Stockbarker techniques, Jokralski technique. This Jokralski is he discovered a method called Jokralski method in 1918 itself. 1918. Bridgman, he developed a techniques in 1925.
Out of Gujarat.
Yes, sir.
Out of Gujarat.
Yes, Jokralski. So 1925 itself, he developed a Bridgman technique. So and then scientist Barker, Stockbarker, he also involved in the Bridgman technique. That technique is called Bridgman Stockbarker technique. Okay.
And how much size have developed?
Yes, sir. So I can show that one in later slides. Okay. So we can grow a bulk single crystals by this technique. directional solidification is possible. Directional solidification means, suppose we can grow a bulk single crystals. When you subject, suppose this is the crystal means, it has the very many planes, okay? So very many directions, okay? So each directions can show different properties, different values of properties. For example, when I subject this material into the yes, these crystals that has the peculiar property that is called directional dependent properties, that is called anisotropic properties. So therefore, in this method, we can grow crystals with specific directions. That is, the directional solidification is possible in this method. Fast growth rate than solution method. Disadvantages also, it has material sensitive to overheating, are difficult to grow by this technique, as well as when you go for the binary, ternary and other quaternary type of materials, we need to, before growth, we need to study the phase diagram of these materials. Without a phase diagram, that is not possible to grow single crystals. Yes, there are n number of melt growth techniques available, that is coined based on the experimental modifications one another. Yes, to provide the required thermal gradient depending on the material's property. This melt growth techniques, so named Bergement technique, Jokralski, Chiropoulos and zone melting and very many techniques. These are all the important technique to grow a bulk single crystals. So from which, as well as the variable technique also, from which we have chosen that vertical bridgement technique initially. So this technique, this is the schematic of vertical bridgement technique. Okay, it consists of 5 important parts. One is furnace we need. So in order to get the temperature, we need to install that heating element. So that is the furnace. Then in order to carry our materials, we need vessel. So that is scientific name is ampule. So or crucible. So we need a crucible materials. In order to translate our crucible materials from hot zone to cold zone, we need a pulley arrangements. That is called a translation assembly. Yes. So this is the simple setup of this schematic of this Bergman system. So here we can grow crystals. Suppose after the arrangement of this furnace, after taking our material in the crucibles, we need to place this crucible in hot zone region. Hot zone region. Yes. So a method of growing single crystal in which this vertical cylinder that tapers conically, this one is the conically, okay, to a point at the bottom. It contains the substance to be crystallized in the molten form. So when you take this material in the hot zone, so we can obtain the molten form or melt form of that materials. Yes, for to grow a single crystals, you see, simply is slowly lowered into the cold zone. Accordingly, we need to set that gradient in the furnace. Okay, so then you see that when you lower this crucible from hot zone to cold zone, what happened? That resulting crystallization at the tip of this crucible initially. Okay, so this one when you do frequently, so we can get that bulk single crystals. But so we need to optimize several parameters. One by one I can discuss here. So as I have already mentioned, material decomposes before melting, cannot be grown by this technique. So we need to optimize the temperature distribution in the furnace as well as the ampule. That is the important parameters. Yes. We can grow crystals or we can get the nucleation at the tip of the ampules by means of 3 methods, by 3 arrangements. One is moving the crucible down the temperature gradient, what I have discussed in the previous one, or otherwise moving the furnace Just you can place these crucibles and take a stationary one here. Just you can move the furnace. So, by means of moving the furnace, we can also attain the nucleation at the tip of the crucibles, or otherwise by keeping both furnace and crucibles so stationary, so by moving or cooling the furnace. This is the three methodology we can follow to attain the nucleation in this, particularly for vertical bridgman systems. Yes. In order to construct, so even we can MSc or MPhil or research scholars, we can easily construct these setups in our laboratory with a minimum cost. So for that, first we need furnace and then heaters, that is the heating elements, then temperature controllers, thermocouples, crucibles, and translation assembly. Yes. So before this one, for making this furnace and other things, we need to select what type of materials we are going to grow as a bulk single crystal. It may be organic or inorganic. Organic means, so we can construct a furnace with a low temperature, means up to 500 degrees centigrade. So we can construct a furnace. For that, we can use a heating element accordingly, as well as the crucible materials. We can choose that one. Suppose we can choose the materials for melting point of 1500 degree. For that, we need to change the heating elements as well as the furnace materials and then crucibles also. For our case, we have chosen that organic material to grow as a bulk single crystals. So simply, so we have constructed a furnace. So I can discuss in the later slides. Yes, indigenous one. Yes. So there are two types of furnace available: low temperature and high temperature furnaces. Low temperature means from room temperature to up to 500 or 600 degrees centigrade. For that, we need to use the different heating elements. For high temperature furnace up to 1500 degree, for that we need to use different heating elements as well as the crucible materials. So here, so we can employ the resistive heating or otherwise the induction heating. So furnace material, these are all the furnace materials: alumina and corundum, glass or quartz. We can use for the constructing this or fabricating the furnace materials. For our case, we use the glass, okay, borosilicate glass, so to design this furnace like this. Okay, so you see this is the outer cylinder, glass cylinder one. Okay, so then this one is the inner cylinder. So inner cylinder only used as a furnace materials. Why this outer cylinder means, in between these two we fill up with the zirconia wool or insulating material in order to, so in order to overcome the dissipation of the, or avoid the dissipation of the heat from the inner cylinder to outside. Okay, so this is the simple dimension of this furnace what we have designed in our laboratory for vertical bridgman systems. Okay, so this is the single zone furnace. Single zone means, so only one zone it contains. So we can if you supply set the temperatures, that can give the that shows the only one temperatures in that furnace. Yes. So but for our case, we need to high temperature region and low temperature region in order to attain the nucleations. So for that, so you see that this is the single zone furnace. In that itself, in that also we have designed three different zones. How that is possible means, so we can vary the winding spaces. By varying the winding space, so we can vary the zones temperatures. Yes, by means of varying that ones, so we have varied the temperature in the hot zone. This is isothermal zone, this is the cold zone. Okay, three different zones we designed here. So yes, which one, ma'am? this one, this is the isothermal zones, constant zone. So there we can set that melting point of that materials. Okay, after crossing this one, in order to obtain the homogeneous melt of that materials, we designed this constant zone. That constant winding exists in this region only. Yes, the winding space is large at this cold zone. Okay, so, this is the crucible materials. Number of crucibles designs I have given here. This is the tapered crucibles. In order to attain the single nucleations, several investigators they have designed this type of crucibles. Okay, this is the in order to grow a crystals with seeded one, so they designed like this. We can use molybdenum type of crucible, silica, iridium with respect to uh, uh, materials melting point. So we can select this crucible materials. Suppose our material that has the melting point of 500 degree, rightly I can choose the 5x one, or otherwise 2000 means I can go for the graphite, or 1000 degree means I can go for the quartz. 1500 means the iridium crucible. So like that, so the scientists they designed a different type of materials. The design of various shapes and size of the crucibles are important to avoid the formation of multinucleation as well as to achieve the single nucleation at the tip of the crucibles. After designing this furnace, we need to study the temperature profile in that furnace. Yes, from top to bottoms. So we recorded the temperature profiles from which we have understand this region is a constant temperature region. Then we can achieve the single nucleation at this region. This is the cold region. Okay. Yes, this is the simple furnace setup. So that is developed by one of my MSc student Sugumar. You see, this is the glass furnace. We can also see the growth front using this viewing window. Okay, it consists of heating elements. This one is the dimmer start. So in order to provide the power to the furnace, so this dimmer start used. So then, so this translation setup, you see the simple one. So ஒரு எம்எஸ்சி ஸ்டூடெண்ட் சார் என்ன சொல்றாரோ அதை பார்த்து செய்யணும்னு அவன் இது பண்றான். சிம்பிளா ஒரு டிரான்ஸ்லேஷன் பண்ணணும் அப்படின்னா நம்ம என்ன பண்ணுவோம், அதுக்கு ஒரு மோட்டர் இருக்கணும், அது இருக்கணும், அது புள்ளி இருக்கணும் அப்படின்னும். ஸோ திஸ் இஸ் தி லைக் வாட்டர் ஃப்ளோட்டிங் டெக்னிக். ஓகே, ஸோ இந்த செட்டப்ல ஜஸ்ட் வாட்டரை அவர் இது நிறச்சிக்கிறாரு. ஸோ அதுக்கு மேல ஒரு வுடன் பீஸ், ஹஸ் டேக்கன் ஒன் வுடன் பீஸ், ஒன் எண்ட் ஆஃப் தட் crucible, இங்க ஒரு சின்ன ஒரு காந்தால் ஒயரை எடுத்துக்கிறாரு. அந்த காந்தால் ஒயரோட ஒன் எண்ட் connected in the crucibles and another end is knotted in this wooden piece. அந்த wooden piece மிதக்கும், நம்மளுக்கு தெரியும், வாட்டர்ல அதை போட்டுறாரு. எஸ், யூசிங் தி பியூரட் ஆர் பிப்பட், ஸோ we can supply a water in this one. எவ்வளோ drop by drop he supplied. ஸோ அப்போ வாட்டர் ஃப்ளோட் ஆயிட்டு அந்த wooden piece ஃப்ளோட் ஆயிட்டு மேலே வருது. By means of this one, so he can achieve that translations. Okay, simple methodology he used there, this one. So after that you see that this is the microprocessor based translation setup. So this one I have designed along with my MSc student. During my PhD I have used this microprocessor based translation setup. So then I have designed this setup, that is the microcontroller based setups, in order to translate the crucibles very minimum rate. So we have designed this one. So we use the methodology, that is when you use the stepper motor for translating these crucibles in microprocessor, one stepping of that motors we can achieve 1.8 degree. Okay, using the microcontrollers programming, so that 1.8 degree divided by 2000. So using this one, So we achieved 4 lakh steps per revolutions. Then, so that is the each step, that is the 30 nanometer translation we achieved here. So that is the very, very low growth rate. So we can achieve for organic materials. That is a very, very important one. Before going to start the growth, we need to understand the thermal properties of materials by means of TGA and DTA, differential scanning calorimetry, DSC, or TGA, thermogravimetric analysis. We can understand the what is the melting point and decomposition point. Suppose this is the melting point, this is the decomposition point. Some organic materials means you see this difference between the melting and the decomposition is very large. Means this is the 90 degree, this one is the 300 degree. Okay, so this type of materials is suitable to grow by this melt growth techniques. Suppose this decomposition point is very nearer to the melting point, that is not possible. Okay, from this study we can understand the thermal properties, then we can choose that material to grow as a bulk single crystals. Okay, so for our case we have chosen this vertical bridgement technique. So 3 important materials, organic materials we have chosen. One is the benzimidazole, that has the SHG efficiency 4.5 times that of this standard potassium dihydrogen orthophosphate. Then this 8 hydroxyquinoline materials, that SHG efficiency, so 4.28 times of KDP. Then the 4 amino benzophenone single crystals, that is a 360 times of ADP, SHG efficiency, second harmonic generation efficiency. The growth procedures, what I have discussed in the initial slide, the same one we followed. The zone refined organic materials was taken in the borosilicate glass crucibles, then vacuum sealed. Then the tapered tip crucibles was designed to achieve the single nucleation at the bottom of the crucibles and to avoid subsequent nucleations. Now the charge was lowered through the lower temperature region to solidify as it approaches the freezing point. This is the simple methodology we followed to grow a benzimidazole single crystals. During the growth, so we have taken this photograph. Here we can easily observe this is the solid liquid interface. This one is the solid, this is the solid material crystal grown. This one, this is the melt form. Okay, so this is the solid or crystal melt interface we can find here, because this crystal melt interface playing a vital role. So we need to obtain that is a flat form of that is a solid liquid interface. Okay, then only we can get the very high quality single crystals. So different form of solid liquid interface we can obtain, convex, concave, or flat one, or planar one. So mostly in order to obtain the good quality single crystals, we need to get that is the flat or planar form of solid liquid interfaces. This is the benzimidazole, doped benzimidazole single crystals grown by this one. These are all the optimized parameters: temperature gradient 4 degrees centigrade and translation rate 1.8 degree. Please.
Convex, concave, how much quality affected, sir?
Definitely growth induced defects we can get, we can obtain there. So very minimum defects also we can get that. Okay, so yes. So initially we need to optimize that one. Then only, so we need to optimize means definitely we need to optimize to obtain that flat interface. For that we adjust that temperature, translation rate, and other things. Okay, so these are all the 3 different interfaces. So that is solid liquid interfaces. So this shows the importance of controlling the interface shape by controlling the experimental parameters which influence the interface shape. Okay, so after the growth, sir,
can be achieved, it is over a period, over a period, the entire period we have to control.
Yes, initially. So for first growth, yes, sir, the first growth. So initial duration for this growth. So it will take 10 to 15 days with uninterrupted power supply.
Okay.
Please. Good.
We need to control to make
For all the growth. Through all the entire the growth, so we need to maintain that flat interface. Yes.
starting from beginning.
Yes, then only we can achieve that good quality single crystals. Or otherwise, convex or concave means definitely that induce the growth defects, dislocations.
How we control?
Yes. Initial growth. So from our initial growth, by trial and error method, by optimizing the growth parameters like temperature and other things. Okay, temperature and translations and other furnace design and crucible design also that may affect the crystal melt interface.
Every day we have to see.
Yes.
We have to see.
Yes, definitely.
Maybe 3 hours.
Sir, 15 இல்ல சொல்றேன் 2 மாசம் இருந்தாலும் 3 மாசமா இருந்தாலும் பையனுக்கு ரிசர்ச் வந்து அதை பார்க்கணும். We need to maintain that one. So yes.
Let's say I'm a student, I'm engaging. How many hours once I have to see? Maybe 3 hours once or 2 hours once. Just maybe you may be standardized. That way I'm asking you.
Yes. So this is not needed to every hour. Initial days we can observe every hour or half a day once we can see. So மற்ற நாள்ல இதெல்லாமே கம்ப்யூட்டர் கண்ட்ரோல்டு. ஸோ நீங்க செட் பண்ணிட்டீங்கன்னா ஸோ நீங்க குரோத்தை பார்க்க தேவையில்லை. பட் இனிஷியல் ட்ரையல் அண்ட் எரருக்கு we need to observe every hour. எப்படி இருக்கு growth, எஸ் எப்படி இருக்கு அப்படின்னு இனிஷியல் ட்ரையல் அண்ட் எரருக்கு பண்ணலாம். ஸோ அது முடிச்சதுக்கு அப்புறம் these are all the optimized parameters கிடைச்சதுக்கு அப்புறம் we can set that parameters, then it can okay. Yes, you see that after the growth, so we examine the crystalline perfection of these materials benzimidazole using the high resolution XRD. So in addition to the main peak, here also we can observe very low angle grain boundaries. That is, grain boundary means, so we expected these orientations, but small amount of other orientation also involved here. That is called very low angle grain boundaries. So in this observing the very low angle grain boundaries is usual in melt growth techniques because of temperature and other fluctuations. Yes, so this is 8 tetraxyquinoline single crystals grown by this vertical bridgement technique. These are all the dimension 52 mm length and 12 mm dia. Here also we have studied that is the crystalline perfections. In addition to the main peak, we observed some very low angle grain boundaries. You see, this main peak with full width of maximum is very low, 35 arc seconds. Okay, means so it refers the or represents the good quality of that materials. Okay, but in addition to the main peak, we have also observed some very low angle grain boundaries. So this is for ABP thermal properties. So here we have used some bulb shaped crucibles in order to separate the chemical impurities. நம்ம வாங்குற chemicalல சில impurities இருக்கும். In order to avoid that one, you see that the density of that material sometimes very high இருக்கும் நம்ம grow பண்ற மெட்டீரியலை விட, that impurities. So that impurities segregate at the bottom of these crucibles. Okay, so then you see that after the growth we can cut and throw this portion. So we used only these portions. Single nucleation started at this portion, so then it grows as a bulk single crystals. So here also we observe the crystalline perfections. Here you see we can observe this main peak, only one peak we observe, but that shows the very large FWHMs. This represents these crystals that has the mosaic black of defects. Okay, so in order to avoid Actually, this type of very low angle boundaries and defects, that is because of the crucibles in vertical bridgement systems. We need to translate the crucible from hot zone to cold zone. So because of this mechanical translations, there is a possibility of vibration during the growth. So that vibrations may induce to growth defects that can induce this type of mosaic black, or otherwise this type of very low angle grain boundaries. In order to avoid this one, so we designed this system that is called vertical dynamic gradient freeze systems. Vertical dynamic gradient freeze systems. Without moving this crucible or furnace, just we can move the temperature distribution from bottom to top, so we can achieve the nucleation as well as the bulk growth. This is the aim of this vertical dynamic gradient freeze systems. You see, this method is a well-known method for inorganic materials like gallium arsenide and indium phosphate. Only one attempt made by the Lan et al. In 1980s. Okay, so after that in benzyl crystals. So after that we designed in India, that is the unique systems. In this the main principle of this one vertical vertical gradient freeze technique is an versatile growth method due to its controlled thermal as well as the vibrational less growth environment.
Sir, here, vertical dynamic gradient, let us say.
Yes.
Gradient,
Yes.
temperature gradient is there. Let us
Yes. Yes.
the temperature gradient, let us say 80 to 60, simply sir, 80 to 50, let us say. The 80 to 50 dynamically varying. Means,
Yes.
let us say 1 point, the variation in temperature may be what is the reason?
Yes.
1 point.
I can discuss elaborately in the next
Okay.
one or two slides. Okay, how we achieved, that is the controlled thermal environment as well as the vibrational growth, the vibrational less growth. You see that in this method, temperature gradient will be moved through the furnace from bottom to top by changing the heating profile alternative zones. Okay, so accordingly, there in vertical bridgement system, we have designed single zone furnace only. In order to get or attain this controlled thermal environment, we divided this single zone into 8 different zones. 8 different zones. Each zone consists of 3 centimeter only. 3 centimeter region only. That is considered as a single zone. Okay, so 8 different zones we have made. So like this is the furnace, enlarged view of this furnace, 8 different zones, the temperature of 8 different zones. So that is the controlled by 8 different controllers. 8 different, very minimum regions of 3 centimeters controlled by 1 controllers. 8 different controllers controlled the temperature of these 8 zones. Then you see that, so these systems consists of these important parts like a furnace. Then we also implemented, that is the programmable logical controller, then translation assembly. So in order to observe the growth fronts, we use the image capturing devices using the CCD camera. We observe the growth feature of this one. So this is the simple schematic of this vertical dynamic gradient freeze system. You see, like a vertical bridgement system, here also we used these are all the features of this vertical dynamic gradient freeze system: 8 zone, computer control, controlled thermal environment, and other things. Okay. All these 8 zones, so controlled by different controllers, as well as so we have also the 8 different sensor sensing that temperatures in the each individual zones. Okay, so here we have used C-type heaters for obtaining that heating temperature in that one. So for that we use nichrome wire. Zone length is 25 centimeters only. Okay, so in between these two zones we have 5 mm gap. 5 mm gap. So in order to design that furnace, we use the quartz tube. Okay, so this is the designed system of vertical dynamic gradient free system. So this one is the control panel. This is a furnace, 8 zone furnace. So this CCD camera. So all this temperature and other things we can control using this PC itself. So using the LabVIEW softwares, we designed that one. So to control, we can set the temperature using this PC or otherwise PLC. Okay, so so this is the 8 zones. So we can also observe that set temperature as well as the what is the real temperature in the furnace, that we can observe using this one. How much of time elapsed, that also we can observe. So then you see that, so every minute, so we can record every second itself, so we can record the zone temperatures, how much temperature it shows, as well as the using the translation setup. This window we can also optimize the translation range. So here the growth procedure is simple. So like in the case of vertical bridgman, here also the materials filled ampoule is subjected to the fine vacuum. Then sealed ampoule has to be kept in the 8 zone furnace. Initially all the zones are set in the same temperature, that is the melting temperature. Like, so I can show the examples. For our case, amino benzophenone materials we have taken for study. So melting point of that material is 121 degree centigrade. Initially all the 8 zone set that is the 121 degree centigrade. Okay, so we have taken the 121 degree centigrade. Now, so we obtain that molten form of that materials, melt form of that materials. In order to achieve the nucleation, so or to move the temperature gradient from bottom to top, initially we reduce or lower the temperature at the bottom source, 2 degree. Yes, so initially 1 degree, so then we lower the 2 degree there. Then we can achieve the nucleation there in the bottom one. So after getting that nucleations, we move to next zone. Now the temperature of the bottom zone is 117 degree, 2 degree reduced. So the 7th zone is 119 degree, the same 2 degree. So because of this one, that is acts like a seed crystals, so we can get the crystals up here. So then by means of reducing the temperature from bottom to top, we can achieve or move the temperature gradient from bottom to top of this one. So by means of these mechanisms, we can grow crystals. So this is the temperature profile of the all the 8 zones after setting that one. So initially all the zones are shows the same temperature. Okay, so then you see the temperature reduce like this.
That is called a
dynamic gradient. Yes, this is the grown single crystals of 4-amino benzophenone during the growth, and then harvested crystals of 4-amino benzophenone materials. Here also we have recorded the high resolution XRD. This is for Bridgman technique. This is vertical Bridgman technique. Here we can obtain that only one peak with FWHM is very large, whereas here this is the main peak. It shows the 160 degree arc second only, whereas here 350 arc seconds. Okay, so in addition to the main peak, here also we observed some very low angle grain boundaries that is not possible to avoid by this melt growth techniques. So we reduce this main peak one. So FWHMs by means of optimizing the temperature as well as the that is the mechanical arresting the mechanical vibrations. Okay, this is the benzimidazole single crystals grown by this vertical Bridgman system, as well as 8 hydroxyquinoline also used to grow by this vertical dynamic gradient systems. The 12 mm dia as well as the 37 mm length. Here we use that double wall crucible in order to avoid the growth defects. Sometimes the outside the temperature can affect the growing single crystals. For that we use the double wall crucibles. Okay, these are all the things we have carried out in our laboratory. So for growing the bulk single crystals. So with this, I would like to conclude my lectures. If you have any doubts, please. Thank you.
Thank you for your wonderful and informative session, sir. Thank you.
Thank you, Ananda.
Thank you, sir. I request everyone to disperse for lunch for 45 minutes and report here by 2:45.